into a space where learning meets relaxation. Find your favorite spot, dim the lights, and let your body sink into comfort. This tutorial is designed to flow gently, like a soft breeze through the trees. Let the words wash over you, and let your mind drift into the world of PHP. As we begin, remember to like and subscribe for more calming coding journeys. Close your eyes if you like, and let the rhythm of this lesson carry you forward. Welcome to the first session of our PHP programming language training course. Today, we will explore the fundamentals of PHP and its role in web development. This course is designed to guide you from basic concepts to advanced techniques, ensuring you gain practical skills to build dynamic websites. PHP remains a cornerstone in modern web development due to its flexibility, widespread use, and integration capabilities with various technologies. By the end of this training, you will be equipped to create interactive and data-driven web applications. PHP, which stands for Hypertext Preprocessor, is a server-side scripting language that plays a crucial role in generating dynamic web content. Unlike client-side languages like JavaScript, PHP runs on the server, allowing it to handle complex tasks such as user authentication, data processing, and database interactions. When a user requests a web page, PHP processes the request, executes the necessary scripts, and sends the resulting HTML back to the user's browser. This makes PHP ideal for creating responsive and personalized web experiences. The journey of PHP began in 1995 when Rasmus Lerdorf developed it as a set of tools for managing his personal website. Initially called Personal Homepage, it evolved into a full-fledged programming language with the release of PHP 3 in 1998. Over the years, PHP has undergone significant improvements, with the latest version, PHP 8x, introduced in 2020. This version includes enhanced performance, new features like JIT compilation, and improved error handling, making PHP more powerful and efficient than ever before. One of the strengths of PHP is its cross-platform compatibility, allowing it to run seamlessly on Windows, Linux, and macOS. It integrates effortlessly with popular databases such as MySQL and PostgreSQL, enabling developers to build robust, data-driven applications. The PHP community is vast and active, providing extensive documentation, forums, and libraries to support developers. Additionally, PHP supports both object-oriented programming and functional programming paradigms, offering flexibility in how you structure your code. In web development, PHP acts as the backbone for handling user interactions and server-side logic. When a user submits a form or navigates to a page, PHP processes the request, retrieves, or updates data from a database, and generates the appropriate HTML response. This dynamic approach allows for personalized content delivery, such as displaying user-specific information or processing payments. PHP also communicates with external APIs to fetch data, making it a versatile tool for building modern web applications. To begin working with PHP, you need to set up a local development environment. A common approach is to install a stack like XAMPP, WAMP, or MAMP, which includes Apache, MySQL, and PHP. Configuring these tools involves setting up the web server, database, and PHP settings to ensure they work together. Once configured, you can test your PHP scripts by running them through a browser or using the command line. This setup allows you to experiment and debug your code without relying on a live server. PHP syntax is straightforward and easy to learn. All PHP code is enclosed within PHP and tags, which tell the server to process the enclosed code. Variables in PHP start with a $sign, such as name equals John, and are used to store data. To display output in a browser, the echo statement is commonly used. Comments can be added using for single-line comments or slash. For multi-line comments, helping to document your code for clarity and future reference. In summary, PHP is a powerful tool for creating dynamic web applications, and understanding its role in server-side development is essential. The next session will dive deeper into PHP syntax, variables, and data types, building on the foundation we've laid today. I encourage you to explore the official PHP documentation, online tutorials, and practice exercises to reinforce your learning. With consistent practice, you'll soon be able to develop your own web applications using PHP. Variables in PHP are essential tools for storing and managing data throughout a program. They act as containers that hold values which can be accessed and modified later. To declare a variable in PHP, you always start with a $ followed by a name, such as name equals John. The name of a variable must begin with a letter or an underscore, and it is case sensitive, meaning age and age are considered different variables. For example, age equals 25 stores a whole number, while a student equals true stores a logical value. These examples demonstrate how variables can hold different kinds of data, making them versatile for various programming tasks. Understanding variable syntax and naming conventions is crucial for writing clean and maintainable code. PHP supports a variety of data types to handle different kinds of information efficiently. These types are broadly categorized into scalar, composite, and special types. Scalar types include integers, floats, strings, and booleans, which represent single values. Composite types like arrays and objects allow you to store multiple values or complex structures. Special types such as null and resource have unique purposes, like representing empty values or managing external resources. Knowing the correct data type for a variable ensures that operations are performed accurately and prevents unexpected errors. For instance, treating a string as a number could lead to incorrect calculations. So, understanding data types is fundamental to writing reliable PHP code. Scalar data types in PHP are the building blocks for storing simple values. Integers are whole numbers without decimal points, such as num equals 100. Floats, also known as doubles, represent decimal numbers like price equals 9.99. Strings are sequences of characters used for text. For example, greeting equals hello. Booleans store logical values, either true or false, as seen in is logged in equals false. Each scalar type has specific use cases. For instance, integers are ideal for counting, floats for precise measurements, strings for handling text, and booleans for decision-making in conditions. Mastering these types allows developers to structure data effectively and perform operations with accuracy. Composite data types in PHP enable the storage of multiple values or complex data structures. Arrays are collections of values that can be accessed using indexes, such as fruits equals apple, banana. This makes it easy to manage lists of items. Objects, on the other hand, are instances of classes and encapsulate data and functions, like person equals new user. Objects are central to object-oriented programming, allowing for more organized and reusable code. By using arrays and objects, developers can handle large data sets, model real-world entities, and create modular programs. These composite types are essential for building scalable and maintainable applications. Special data types in PHP serve unique roles that go beyond basic data storage. The null type represents a variable with no value, often used to initialize variables or indicate the absence of data, such as value equals null. Resources are handles for external entities like database connections or file pointers, which are managed by PHP. For example, a database connection might be stored in a resource variable. These types are critical for advanced programming tasks, ensuring that resources are properly allocated and released. Understanding null and resource types helps developers manage system-level operations and avoid leaks or errors in their applications. Variables and data types form the foundation of programming in PHP, enabling the storage, manipulation, and retrieval of data. Choosing the appropriate type for each variable ensures that your code runs efficiently and avoids unexpected behavior. For example, using an integer instead of a string for numerical calculations prevents errors. Practicing with real-world scenarios, such as building a form validation system or managing user data, reinforces these concepts. By mastering variables and data types, you lay a strong groundwork for more complex programming tasks. Continuously applying these principles in projects will enhance your ability to write robust and error-free PHP code. Operators are symbols that perform operations on variables and values. Think of them as the tools that allow you to manipulate data in your code. For example, when you add two numbers or compare two strings, you're using operators. Expressions, on the other hand, are combinations of variables, constants, and operators that evaluate to a single value. These elements work together to form the logic behind your programs. Whether you're calculating a result, making a decision, or modifying data, operators and expressions are the foundation of how PHP processes information. Understanding them is crucial for writing effective and efficient code. Arithmetic operators include addition, subtraction, multiplication, division, and modulus. These operators let you perform basic mathematical operations. For instance, the plus symbol adds two numbers, while the minus symbol subtracts one from another. multiplication and division work as expected, but modulus is unique because it returns the remainder of a division operation. This is particularly useful for tasks like determining if a number is even or odd. For example, when you use the modulus operator with 10 and 3, the result is 1, which is the remainder after dividing 10 by 3. These operators are essential for any calculation you might need in your PHP scripts. Assignment operators are used to assign values to variables. The simplest form is the equals sign, which directly assigns a value. However, compound assignment operators like plus equals, minus equals, multiply equals, divide equals, and modulus equals allow you to perform an operation and assign the result in one step. For example, if you have a variable x set to 10, using x plus equals 5 will increase its value to 15. This shorthand notation not only makes your code more concise, but also reduces the chance of errors by minimizing repetitive code. These operators are especially helpful when you need to update a variable's value based on its current state. Comparison operators are used to compare values and determine relationships between them. The equality operator checks if two values are the same, while the identity operator checks if they are the same in both value and type. This distinction is important because PHP automatically converts data types in some cases, which can lead to unexpected results. For example, if you compare a string 5 with the number 5 using the equality operator, they will be considered equal, but with the identity operator, they will not. Other comparison operators, like greater than and less than, help you evaluate conditions in your code, such as checking if a variable meets a specific threshold. Logical operators allow you to combine multiple conditions in your code. The AND operator, represented by 2 ampersands, requires both conditions to be true for the overall expression to evaluate to true. The OR operator, represented by 2 vertical bars, requires at least one condition to be true. The NOT operator, which is a single exclamation mark, inverts the truth value of a condition. Lastly, the XOR operator, which is written as SOR, returns true only if exactly one of the conditions is true. These operators are essential for creating complex decision-making structures in your programs, enabling you to handle a wide range of scenarios. Increment and decrement operators are used to increase or decrease a variable's value by 1. The pre-increment operator, which is written as double plus before the variable, increases the value before it is used in an expression. The post-increment operator, written as double plus after the variable, increases the value after it is used. Similarly, the pre-decrement and post-decrement operators work the same way, but with subtraction. For example, if you have a variable x set to 5 and use the pre-increment operator, the value becomes 6 before it is used in any further calculations. Understanding the difference between pre and post versions is crucial for avoiding unexpected results in your code. String operators are used to work with text in PHP. The concatenation operator, which is a dot, joins 2 strings together. For instance, if you have 2 variables containing hello and world, using the concatenation operator will combine them into hello world. The concatenation assignment operator, which is a dot followed by an equal sign, appends a string to an existing variable. This is useful for dynamically building strings, such as adding a message to a variable that already contains some text. These operators are fundamental for tasks like generating dynamic content or manipulating user input. The conditional operator, also known as the ternary operator, provides a shorthand way to write simple if-else statements. Its syntax is condition, true expression, false expression. This means that if the condition evaluates to true, the true expression is executed. Otherwise, the false expression is executed. For example, if you want to assign a value based on whether a variable is greater than another, you can use the ternary operator to do this in a single line. This operator is particularly useful for keeping your code concise and readable, especially when dealing with simple conditional logic. Operator precedence determines the order in which operations are performed in an expression. By default, certain operators take priority over others, such as arithmetic operations being evaluated before comparisons and logical operations. However, parentheses can override this default order, allowing you to control which parts of an expression are evaluated first. For example, in the expression a plus b multiplied by c, the addition inside the parentheses is performed before the multiplication. Understanding operator precedence helps you write accurate and predictable code, especially when dealing with complex expressions that involve multiple operators. Expressions in PHP are any valid code that evaluates to a single value. This includes simple assignments, such as x equals 5 plus 3, where the result is 8. Expressions can also be used in control structures, like if statements, where a condition is evaluated to determine the flow of the program. For instance, the expression a greater than 10 might be used to decide whether to execute a block of code. Because expressions are fundamental to how PHP processes information, mastering them allows you to create more dynamic and responsive applications. When working with operators and expressions, it's important to follow best practices to ensure your code is clear and maintainable. Using parentheses to explicitly define the order of operations can prevent confusion and make your intentions clear to others who may read your code. Avoiding overloading operators with ambiguous logic helps prevent bugs and makes your code easier to understand. Prioritizing readability over brevity ensures that your code is accessible to other developers and easier to debug. By adhering to these guidelines, you can create more reliable and efficient PHP programs. Operators and expressions are fundamental to the logic and functionality of PHP. They enable you to perform calculations, make decisions, and manipulate data in your applications. Mastering these concepts allows you to write more efficient and effective code, which is essential for building robust web applications. By practicing how to combine operators in real-world scenarios, you can develop a deeper understanding of how PHP works and improve your ability to solve complex programming problems. Keep experimenting with different combinations to strengthen your skills and become more proficient in PHP. Conditional statements are a fundamental concept in programming that allow developers to control the flow of a program based on specific conditions. These statements enable the execution of different code blocks depending on whether a condition evaluates to true or false. In PHP, the primary keywords used for implementing conditional logic are if, else, else if, and switch. These tools are essential for creating dynamic and responsive applications, as they allow the program to make decisions and adapt its behavior accordingly. Understanding how to use these statements effectively is crucial for writing efficient and readable PHP code. The if statement is the most basic and widely used conditional structure in PHP. It allows you to execute a block of code only if a specified condition is true. The syntax for an if statement is straightforward. You start with the keyword if, followed by a condition in parentheses, and then a code block enclosed in curly braces. For example, if the variable age is greater than or equal to 18, the code inside the if block will run, outputting the message adult. This structure is particularly useful for scenarios where you want to perform an action only under specific circumstances, such as checking user input or validating data. The else statement complements the if statement by providing an alternative code block to execute when the if condition is false. This creates a binary decision-making structure where either the if block or the else block runs, but not both. The syntax involves placing the else keyword immediately after the if block, followed by another code block in curly braces. For instance, if the variable score is greater than 50, the code will output pass. But if it is not, the else block will execute, displaying fail. This is particularly useful in situations where you need to handle two distinct outcomes, such as determining whether a user has passed a test or not. The else if statement extends the functionality of the if and else statements by allowing you to check multiple conditions sequentially. This is particularly useful when you have several possible scenarios to evaluate. The syntax involves chaining multiple else if conditions after the initial if statement, followed by an optional else block for a default case. For example, if the variable grade is 90 or higher, the code will output A. But if it is 80 or higher, it will output B. This structure is ideal for scenarios with multiple thresholds, such as grading systems or role-based access control, where different actions are required based on varying values. Nested conditional statements involve placing one condition inside another, allowing for more complex decision-making processes. This approach is useful when you need to evaluate multiple layers of conditions, such as checking whether a user is logged in, and then determining their role. The syntax for nesting involves placing an if statement inside another if, else if, or else block. For example, if the variable user logged in is true, you might check another condition to see if the user is an administrator. While nesting can be powerful, it should be used judiciously to avoid creating overly complicated code that is difficult to maintain. The switch statement provides an alternative way to handle multiple conditions by evaluating a variable against a series of predefined values. This structure is particularly useful when you have a single variable that can take on several distinct values, such as days of the week or user roles. The syntax starts with the switch keyword, followed by the variable in parentheses, and then a series of case blocks that specify possible values. For example, if the variable day is Monday, the corresponding code block will execute. The switch statement is often more readable than multiple else if statements when dealing with a large number of possible values. The default keyword in a switch statement acts as a fallback option when none of the specified cases match the variable being evaluated. This is similar to the else statement in if-else chains and ensures that some code is executed even if unexpected values are encountered. For instance, if the variable day does not match any of the defined cases, the default block will run, displaying invalid day. This feature is essential for handling edge cases and improving the robustness of your code, as it prevents unhandled scenarios from causing errors. When working with conditional logic, it is important to follow best practices to ensure your code remains clean, readable, and maintainable. One key principle is to keep conditions simple and avoid overly complex expressions that can be difficult to understand. Instead of using nested if statements for multiple checks, it is often better to use else if to create a linear flow of conditions. Additionally, excessive nesting can lead to code that is hard to debug. So it is advisable to limit the depth of nested conditions. By adhering to these practices, you can create more efficient and reliable PHP applications. Conditional statements are widely used in real-world PHP applications to handle a variety of scenarios. For example, in user authentication, conditions can check whether a user is logged in or has the appropriate permissions to access certain features. In form validation, conditions can verify that input data meets specific criteria, such as checking for valid email formats or password strength. Additionally, conditional logic is essential for displaying dynamic content based on user roles, such as showing administrative options only to users with elevated privileges. These use cases demonstrate how conditional statements are integral to building interactive and responsive web applications. In summary, conditional statements are a cornerstone of PHP programming, enabling developers to create programs that make decisions and respond to different situations. Mastering the if-else and switch statements allows you to write more powerful and flexible code that can handle a wide range of scenarios. By practicing the creation of clean, efficient conditionals, you can improve your ability to solve complex problems and build robust applications. As you continue to explore PHP, remember that understanding and applying conditional logic effectively will significantly enhance your coding capabilities. Loops are a fundamental concept in programming that allow us to execute a block of code multiple times. This repetition is essential for handling tasks that require repeated actions without writing the same code over and over again. By using loops, we can significantly reduce redundancy in our code, making it more efficient and easier to maintain. In PHP, there are 3 primary looping structures that we can use depending on the specific requirements of our program. These are the for loop, the while loop, and the for each loop. Each of these loops serves a unique purpose and is suited for different scenarios. Understanding how to use them effectively will greatly enhance our ability to write clean and powerful PHP code. The for loop is one of the most commonly used loops in PHP. Its syntax consists of 3 main components: initialization, condition, and increment. The initialization step sets the starting value of a counter variable. The condition determines whether the loop should continue running, and the increment updates the counter after each iteration. This structure is particularly useful when we know exactly how many times we want a block of code to execute. For example, if we need to display numbers from 1 to 5, the for loop provides a straightforward and efficient way to accomplish this. The code in this example initializes a variable I to 1, checks if I is less than or equal to 5, and increments I by 1 after each iteration. This process continues until the condition is no longer true, ensuring the loop runs exactly 5 times. The while loop is another essential looping structure in PHP, but it operates differently from the for loop. Instead of having a built-in initialization and increment step, the while loop relies on a condition that is evaluated before each iteration. If the condition is true, the code block inside the loop is executed. This makes the while loop ideal for situations where the number of iterations is not known in advance. For instance, in the example provided, we start by initializing I to 1 and then check if I is less than or equal to 5. If the condition is met, the code inside the loop runs and I is incremented. This process repeats until I exceeds 5, at which point the loop stops. It is crucial to ensure that the condition eventually becomes false to avoid infinite loops, which can cause our programs to crash or become unresponsive. The for each loop is specifically designed for iterating over arrays in PHP. Its syntax is straightforward, as it directly accesses each element of an array without the need for manual index management. This makes it an excellent choice for working with collections of data, such as lists or associative arrays. In the example, we have an array called fruits containing 3 elements: apple, banana, and cherry. The for each loop assigns each element to the variable fruit and executes the code block for each value. This approach simplifies the process of looping through arrays, reducing the risk of errors that can occur with other loop types. Whether we are processing form data, reading files, or manipulating database results, the for each loop is an invaluable tool for handling array-based operations efficiently. Each of the 3 looping structures for while and for each has its own strengths and is best suited for specific tasks. The for loop is ideal when we have a clear idea of how many times a block of code should run, such as counting from 1 to a specific number. The while loop is more flexible and is used when the number of iterations depends on a dynamic condition that may change during execution. The for each loop, on the other hand, is tailored for working with arrays, allowing us to easily access each element without managing indices manually. Choosing the right loop for a given task can improve code readability, performance, and maintainability. For example, using a for loop for a counter-based task, a while loop for user input validation, and a for each loop for processing array elements ensures that our code is both efficient and easy to understand. In conclusion, loops are a cornerstone of programming that enable us to automate repetitive tasks and streamline our code. By mastering the for, while, and for each loops, we gain the ability to handle a wide range of programming challenges with greater efficiency. These structures are not just tools for writing code. They are essential for building dynamic and responsive applications. As we continue to practice and apply these concepts in real-world scenarios, we will develop a deeper understanding of how to leverage loops effectively. Whether we are working on simple scripts or complex web applications, the ability to use loops proficiently will significantly enhance our PHP programming skills. Let us continue to explore and experiment with these loops to unlock their full potential in our projects. Functions are reusable blocks of code that perform specific tasks. By breaking down complex programs into smaller, manageable functions, we can significantly improve code organization, readability, and maintainability. Imagine writing a large program without functions. Every time you needed to perform a task, you would have to rewrite the same code multiple times. That would not only be inefficient, but also error-prone. PHP provides a wide range of built-in functions, such as strlen to measure string length and echo to output data. However, the true power of PHP lies in its ability to create user-defined functions tailored to your specific needs. These custom functions allow you to encapsulate logic, making your code more modular and easier to debug. To define a function in PHP, we use the function keyword followed by the function name and a set of parentheses that may contain parameters. The syntax is straightforward. Function name parameters. For example, a simple function called greet could be created to output a welcome message. When this function is called, the code inside its curly braces executes. This structure allows us to reuse the same block of code multiple times without rewriting it, which is a fundamental principle of efficient programming. Let me demonstrate this with an example. Parameters are the variables listed in the function definition, while arguments are the actual values passed to the function when it is called. For instance, consider a function called add that takes two parameters, a and b. When we call this function with specific values, like add 3, 5, the arguments 3 and 5 are assigned to the parameters. A and b, this mechanism allows functions to handle different inputs dynamically. Parameters can be of any data type, including integers, strings, arrays, or even other functions. By designing functions with parameters, we make them flexible and adaptable to various scenarios. Functions can return data to the caller using the return statement. This is essential for tasks such as performing calculations and passing the result back to the rest of the program. For example, a function named multiply could take two parameters, x dollars and y, and return their product. The returned value can then be used in expressions, stored in variables, or even passed to other functions. This capability makes functions powerful tools for building complex applications. By returning values, functions act as self-contained units that can be integrated into larger programs seamlessly. Variables declared inside a function have a local scope, meaning they are only accessible within that function. This helps prevent unintended side effects and keeps the code organized. However, there are situations where we need to access variables from outside the function. To do this, we can use the global keyword to bring the variable into the function's scope. For example, if a global variable global var is defined outside a function, we can declare it as global inside the function to access its value. Additionally, PHP provides superglobals like get and post, which are accessible from any scope. Understanding scope is crucial for managing data flow and avoiding conflicts in larger applications. User-defined functions are custom functions created by the developer to address specific requirements. These functions are essential for building unique solutions that go beyond the capabilities of built-in functions. When creating user-defined functions, it is important to follow naming conventions such as camel case or snake case to ensure clarity and consistency. For instance, a function to calculate the area of a rectangle might be named calculate rectangle area. Documenting functions with comments or PHP doc blocks also enhances readability and makes it easier for others to understand and use the code. By adhering to these practices, we create a more maintainable and collaborative code base. Following best practices when writing functions ensures that the code remains clean, efficient, and easy to maintain. One key principle is to keep functions focused on a single task, which makes them easier to test and debug. For example, a function should not handle both data processing and user input validation unless it is explicitly designed for that purpose. Avoiding global variables by passing parameters instead reduces the risk of unintended side effects and makes functions more self-contained. Additionally, Using descriptive names for functions and parameters improves readability, allowing developers to quickly understand the purpose of each function without diving into its implementation. In conclusion, functions are a cornerstone of PHP programming, offering significant benefits in terms of reusability, modularity, and flexibility. By leveraging both built-in and user-defined functions, developers can write more efficient and scalable applications. The ability to break down complex problems into smaller, manageable tasks through functions is a skill that every PHP programmer should master. As you continue your journey, practice creating and calling functions in various scenarios to deepen your understanding. The more you experiment, the more proficient you will become in utilizing functions to build robust and maintainable code. Arrays are a fundamental data structure in PHP that allow you to store multiple values in a single variable. This makes it easier to manage and organize related data. For example, instead of creating separate variables for each fruit, you can store them all in an array. PHP supports three main types of arrays: indexed arrays, which use numeric keys; associative arrays, which use string keys for more descriptive access; and multi-dimensional arrays, which can hold arrays within arrays. These structures are essential for handling collections of data efficiently, whether you're working with user inputs, database results, or complex data sets. Understanding arrays is a critical step in mastering PHP programming. Indexed arrays are the most straightforward type, using numeric keys to access elements. For instance, a list of fruits can be stored as an indexed array like fruits equals apple, banana. This allows you to retrieve elements by their position, starting from 0. Associative arrays, on the other hand, use string keys, making them ideal for situations where you need to reference data by name. An example is ages equals John equals 25, where John is the key and 25 is the value. Multi-dimensional arrays take this a step further by containing other arrays, such as a matrix represented as matrix equals 12, 34. These arrays are powerful for modeling real-world scenarios like tables, databases, or hierarchical data structures. Declaring arrays in PHP can be done using the array function or the more modern square bracket syntax. For example, numbers equals 1, 2, 3 is equivalent to numbers equals array 1, 2, 3. Accessing elements is straightforward by using the key in square brackets. If you have an indexed array, you use numeric keys like number 0, which would return the first element. For associative arrays, you use the string keys, such as ages John, to retrieve specific values. This flexibility allows you to work with data in a way that suits your application's needs. Whether you're dealing with simple lists or complex key-value relationships, PHP provides several built-in functions to work with arrays. The count function returns the number of elements in an array, which is useful for loops or determining the size of a dataset. The ArrayMap function applies a specified function to each element of an array, making it easy to transform data, such as converting all strings to uppercase. The ArrayFilter function allows you to filter elements based on a condition, like removing empty values or selecting only even numbers. Finally, the ArrayMerge function combines multiple arrays into one, which is handy when aggregating data from different sources. These functions streamline array operations and reduce the need for manual loops. Manipulating arrays involves adding, removing, and sorting elements. To add elements to an array, you can use ArrayPush to append one or more values, or simply use the square bracket syntax like array equals value. Removing elements can be done with ArrayPop, which removes the last element, or unset, which deletes a specific element by its key. Sorting arrays is another essential task. The sort function arranges elements in ascending order, while a sort sorts by value, but keeps the keys intact. Ksort sorts by key, which is useful for associative arrays. These techniques help keep your data organized and ready for further processing. Arrays are incredibly versatile and find applications in various scenarios. For instance, associative arrays are perfect for storing user data, such as a profile with keys like name, email, and age. Indexed arrays are commonly used for processing form inputs, where multiple selections or repeated fields are submitted. Multi-dimensional arrays come into play when building dynamic tables, such as displaying a list of products with their prices and quantities. By leveraging the right array type, you can structure your data effectively, making it easier to retrieve, modify, and display information in your PHP applications. In summary, arrays are a cornerstone of PHP programming, enabling efficient data management and manipulation. Mastering array functions and techniques enhances your ability to write clean, efficient code. Whether you're handling user inputs, processing data, or building complex structures, arrays provide the flexibility and power needed for real-world applications. Practicing with different array scenarios will solidify your understanding and improve your problem-solving skills. As you continue learning PHP, remember that arrays are a tool you'll use frequently. So, investing time in mastering them will pay off in your development journey. A string is a sequence of characters used to store and manipulate text. In PHP, strings can be enclosed in either single or double quotes, which allows for flexibility in how data is handled. For example, single quotes are useful when you want to avoid variable interpolation, while double quotes allow for variables to be parsed directly within the string. Common operations include concatenation, which is the process of joining two or more strings together. Modification, such as changing the case of characters, and searching for specific substrings within a string. These operations are essential for tasks like processing user input, generating dynamic content, and manipulating text data in applications. To declare a string in PHP, you can use single quotes like str equals hello, or double quotes like str equals world. Single quotes are ideal for simple strings where you do not need to include variables or special characters, while double quotes allow for variable substitution and the inclusion of escape sequences. For multi-line strings, the Heredoc syntax is particularly useful. This syntax starts with "oud" followed by the string content and ends with "eod" on a new line. Heredoc is especially handy when working with large blocks of text that span multiple lines, as it avoids the need for excessive escaping. String concatenation in PHP is achieved using the dot operator, which is represented as a period. For instance, full equals PHP. Training combines the two strings to form PHP training. This operator can also be used to concatenate variables, such as greeting equals hello, name, where name is a variable containing a user's name. Additionally, the dot operator can be used with numbers and other data types, converting them into strings automatically. This makes it a versatile tool for building dynamic strings in your code. The strlen function is used to determine the length of a string. For example, strlen PHP returns 3 because there are 3 characters in the string. This function is particularly useful for validation tasks, such as ensuring that a user's input meets specific length requirements. It is important to note that strlen is case sensitive and counts bytes rather than characters. This means that in a multi-byte character set, such as UTF-8, the function may not accurately reflect the number of actual characters. For such cases, the mbstrlen function is recommended. The strpos function is used to find the position of a substring within a string. For example, strpos hello, E returns 1, as the letter E is located at the second position in the string. If the substring is not found, the function returns false. This makes it a valuable tool for searching and parsing text, such as checking if a specific word exists within a larger string. It is important to remember that strpos is case sensitive, so searching for E in hello will return false. The subster function allows you to extract a substring from a larger string. For example, subster PHP 02 returns PH by starting at the first character and taking the next 2 characters. This function also supports negative indices, which allow you to extract characters from the end of the string. For instance, subster PHP -2 returns HP. Subster is commonly used for tasks such as slicing strings, trimming unnecessary parts, or processing specific segments of text. The strreplace function is used to replace all occurrences of a substring within a string. For example, strreplace a x banana returns bxnxx by replacing each a with x. This function can also handle arrays, allowing for multiple replacements at once. For instance, you can pass an array of search values and an array of replacement values to replace several substrings simultaneously. By default, strreplace is case sensitive, so it will not replace substrings that differ in case. The strtolower and strtuper functions are used to convert strings to lowercase and uppercase, respectively. For example, strtolower PHP converts the string to PHP, while strtuper PHP converts it to PHP. These functions are particularly useful for case-insensitive comparisons, such as checking if a username matches a specific format, regardless of how it is entered. They are also helpful in normalizing user input for storage or display. String manipulation in PHP involves several techniques, including splitting strings using the explode function, which divides a string into an array based on a specified delimiter. The split function, although deprecated, was previously used for similar purposes. To remove white space from the beginning, end, or both sides of a string, you can use trim, ltrim, and rtrim. For formatting strings, the sprint and vsprint functions allow you to create formatted strings similar to how you would use printf in C. These tools are essential for tasks like generating reports, processing user input, and constructing dynamic messages. Strings are fundamental for text processing in PHP, as they form the basis of nearly all data manipulation tasks. Mastering string functions such as strlen, strpos, and strreplace significantly improves your ability to handle and process data efficiently. By practicing these functions in real-world scenarios, you can enhance your coding skills and build more robust applications. Whether you are validating user input, generating dynamic content, or parsing text, a strong understanding of string manipulation is crucial for any PHP developer. Forms are a fundamental part of web development because they enable users to interact with web applications by entering data. This data can be anything from login credentials to contact information, or even complex forms with multiple fields. In PHP, we handle this data using superglobal arrays such as get and post. These arrays act as containers for data sent from the browser to the server. For instance, when a user submits a form, the data is either appended to the URL as query parameters using the GET method, or sent in the body of the HTTP request using the post method. The choice between these methods depends on the nature of the data, such as whether it is sensitive or requires a larger volume of information. Understanding how to create and manage forms using HTML's form tags is essential. The method attribute in the form tag specifies whether the data is sent via GET or post, which directly affects how the server processes the request. This foundational knowledge is critical for building dynamic web applications where user input drives functionality. When working with form data in PHP, the get and post superglobals are the primary tools for retrieving information. The GET method appends data to the URL as key value pairs, making it ideal for retrieving data that does not require high security, such as search queries or pagination parameters. For example, a URL-like example Bedtime.com, name equals John demonstrates how data is passed through the query string. On the other hand, the post method sends data in the body of the HTTP request, which is more secure for sensitive information like passwords or credit card details. This method is also better suited for larger data sets. In HTML, the method attribute of the form tag determines which of these superglobals is used. It is crucial to remember that regardless of the method chosen, input validation and sanitization are mandatory. This ensures that the data is both safe and correctly formatted, preventing issues like injection attacks or malformed entries that could disrupt the application's functionality. Security is a critical aspect of form handling in PHP, as unvalidated or unsanitized input can lead to serious vulnerabilities. One of the most common threats is cross-site scripting, where malicious scripts are injected into web pages viewed by other users. To mitigate this, the HTML special chars function converts special characters into their corresponding HTML entities, preventing unintended script execution. Another essential practice is data validation using functions like filter_var or filter input, which check if the data meets specific criteria, such as a valid email format or numeric value. When dealing with databases, it is vital to avoid directly inserting user input into SQL queries. Instead, prepared statements with parameterized queries should be used to prevent SQL injection attacks. Additionally, cross-site request forgery, CSRF, is a risk when processing post requests, as an attacker could trick a user into submitting a malicious request. To counter this, CSRF tokens are generated and verified on the server side, ensuring that the request originates from a trusted source. These measures collectively enhance the security of form handling in PHP applications. Form validation is a crucial step in ensuring the integrity and reliability of user input. The first step is to check for required fields, which can be done using functions like isEt or empty. For example, if a form requires a username, the script must verify that this field is not left blank. Beyond checking for presence, data type validation is necessary. Functions like filter_var can be used to confirm that an email address follows the correct format, or that a numeric value is indeed a number. For more complex validation rules, regular expressions with the pragmatch function provide flexibility. For instance, a password might need to meet specific criteria, such as containing a mix of uppercase and lowercase letters. It is also important to provide clear and user-friendly error messages when validation fails. These messages guide users toward correcting their input, improving the overall user experience. By implementing thorough validation techniques, developers can reduce errors and ensure that the application behaves as expected. To illustrate the practical application of form handling in PHP, let's consider a few examples. A simple login form typically uses the post method to securely transmit a username and password to the server. The server then processes this data, verifies the credentials, and grants access if valid. Another example is a contact form that uses the GET method to pass query parameters, such as a subject or message, allowing the form to be shared via a URL. File uploads require the use of the FILES superglobal, which stores information about the uploaded file, such as its name, type, and temporary location on the server. Handling files involves checking for errors, validating the file type, and moving the file to a secure directory. For more complex scenarios, such as multi-step forms, session-based validation can be used to store user input across multiple pages. This approach ensures that data is retained between steps, providing a seamless user experience. These examples demonstrate the versatility of form handling in PHP and how it can be adapted to various use cases. Despite the power of form handling in PHP, there are several common pitfalls that developers must avoid. One of the most significant is forgetting to sanitize user input, which can lead to vulnerabilities such as XSS or SQL injection. For example, if a user inputs a script tag into a comment field and it is not properly escaped, it could execute on other users' browsers. Another issue is not handling empty or malformed inputs, which can cause runtime errors or unexpected behavior. For instance, if a required field is left blank, the script might attempt to process an undefined variable, resulting in a fatal error. Overlooking form method mismatches, such as using GET for sensitive data, can expose information in the URL, which is visible to anyone with access to the browser history or server logs. Additionally, browser caching can cause issues when submitting forms, as the browser might reload a previous version of the form, instead of processing the latest input. Developers should be vigilant in addressing these challenges to ensure the reliability and security of their applications. In conclusion, forms are an essential component of PHP applications, enabling dynamic interactions between users and the server. They allow data to be collected, processed, and stored, forming the backbone of many web functionalities. However, the security and reliability of these interactions depend heavily on how the data is handled. Always validate and sanitize user inputs to prevent malicious attacks and ensure data integrity. When deciding between GET and POST methods, consider the nature of the data. Use GET for read-only operations and POST for sensitive or large data. Finally, adopting good coding practices such as thorough validation, secure database interactions, and proper error handling will help create robust and safe form handling systems. By following these principles, developers can build applications that are both functional and secure. Welcome to this session on sessions and cookies in PHP. Understanding these concepts is essential for building dynamic web applications that can maintain user state across multiple interactions. Web applications are inherently stateless, meaning each request is independent. However, sessions and cookies allow us to store information about users, enabling features like login systems, personalized content, and shopping carts. By the end of this presentation, you will gain a clear understanding of how these mechanisms work, how to implement them effectively, and how to secure them against potential vulnerabilities. Let's begin by exploring what sessions and cookies are and why they matter. Sessions are a powerful tool in PHP for storing user-specific data on the server. Unlike cookies, which are stored on the client side, sessions keep data securely on the server, making them ideal for sensitive information. Each user is assigned a unique session ID, which acts as a key to retrieve their data. This session ID is typically stored in a cookie or passed through URLs, allowing the server to recognize the user across different pages. The data associated with a session persists until the user ends the session, such as by closing the browser or logging out. This makes sessions perfect for managing user authentication and temporary data storage. The process of using sessions in PHP begins with the session start function. This function initializes a session and checks if if a session ID already exists for the user. If not, it generates a new one. Once a session is started, data can be stored in the session superglobal array, which is accessible across all pages of the application. The session ID is then passed between the server and browser, typically via cookies, ensuring that the user's data remains consistent. However, if cookies are disabled, PHP can use URL rewriting to append the session ID to the URL. Though this method is less secure and less common, understanding how sessions work is crucial for building reliable and scalable web applications. Cookies, on the other hand, are small data files stored directly on the user's browser. They are used to remember preferences, track user activity, or store lightweight information. For example, a cookie might store a user's preferred language or keep them logged in between sessions. Unlike sessions, cookies are stored on the client side, which means they can be modified or accessed by the user. However, this also makes them less secure for sensitive data. Cookies are sent back to the server with every request, allowing the server to retrieve the stored information. This makes them ideal for scenarios where the data does not need to be kept private, such as tracking user behavior or storing non-critical settings. To create a cookie in PHP, we use the setCookie function. This function allows you to specify the cookie's name, value, expiration time, and other attributes like path, domain, and security settings. Once set, the cookie is stored in the browser's cookie jar and becomes available to the server through the cookie superglobal array. For instance, if you set a cookie named userprefs with a value of dark mode, the server can later access this value using cookie userprefs. However, cookies have limitations, such as a maximum size of 4 KB, which means they are not suitable for storing large amounts of data. It's important to use cookies judiciously and only for their intended purposes. When choosing between sessions and cookies, it's important to consider their strengths and weaknesses. Sessions are server-side, meaning the data is stored securely on the server, making them more suitable for sensitive information. They rely on a session ID, which is typically stored in a cookie or passed via the URL. Cookies, on the other hand, are client-side and stored directly on the user's browser, making them less secure but more convenient for lightweight tasks. Cookies have a size limit of 4 KB, which restricts their use for large data sets. Sessions are ideal for maintaining user state across multiple pages, while cookies are better suited for storing non-sensitive, user-specific preferences. Understanding these differences helps in making informed decisions about which method to use in different scenarios. Security is a critical aspect of both sessions and cookies. For sessions, the primary concern is protecting the session ID from being stolen. Attackers can hijack a session if the ID is transmitted insecurely. So always use HTTPS to encrypt data between the browser and server. Additionally, avoid exposing session IDs in URLs, as they can be logged or intercepted. For cookies, always use the secure and HTTP-only flags. The secure flag ensures cookies are only sent over HTTPS, while the HTTP-only flag prevents JavaScript from accessing the cookie, reducing the risk of cross-site scripting XSS attacks. Never store sensitive information like passwords or credit card details in cookies, as they can be easily compromised. Prioritizing security ensures that both sessions and cookies are used responsibly and safely. PHP provides several built-in functions and superglobals for working with sessions and cookies. The session start function is essential for initializing a session and making the session array available. This function must be called before any output is sent to the browser, as it sets headers that cannot be modified afterward. To create a cookie, use the setCookie function, which allows you to define the cookie's name, value, expiration, and other attributes. The session and cookie arrays are used to access session and cookie data, respectively. Finally, the session destroy function is used to end a session, which is crucial for logging users out and freeing up server resources. Familiarizing yourself with these functions ensures you can implement sessions and cookies effectively in your PHP applications. Sessions and cookies are widely used in real-world applications to enhance user experience and functionality. One common use case is user authentication, where a session is used to store the user's login status. For example, after a user logs in, their ID is stored in the session, allowing the server to verify their identity on subsequent requests. Another example is shopping cart persistence, where session data keeps track of items added by the user, even if they navigate away from the page. Cookies are also used for tracking user preferences, such as language settings or theme choices, making the application more personalized. By leveraging these tools, developers can create interactive and user-friendly web experiences. Despite their usefulness, sessions and cookies can lead to common pitfalls if not handled properly. Forgetting to call session start before accessing session data will result in errors, as the session will not be initialized. Storing large amounts of data in cookies is another mistake, as they have a strict size limit and can cause performance issues. Additionally, failing to destroy sessions when a user logs out can leave sensitive data vulnerable to session hijacking. Always ensure that session data is properly cleaned up and that cookies are set with appropriate security flags. By avoiding these common mistakes, you can ensure your applications are both functional and secure. In summary, sessions and cookies are fundamental tools for managing state in PHP applications. Sessions provide secure server-side storage, while cookies offer lightweight client-side storage. Choosing between them depends on the specific requirements of your application, such as security needs, data size, and use case. By following best practices for implementation and security, you can effectively use these mechanisms to enhance user experience and application functionality. Remember to always prioritize security, avoid common pitfalls, and use these tools responsibly. With this knowledge, you are now equipped to implement sessions and cookies in your PHP projects with confidence. File handling in PHP is a fundamental aspect of programming that allows developers to interact with files on a server. This capability enables reading, writing, and manipulating files, which is essential for tasks such as logging application data, storing user information, or managing configuration settings. By leveraging built-in functions, PHP simplifies these operations, making it easier for developers to handle files without needing complex external libraries. Whether you are creating a simple text file or managing large datasets, understanding file handling is a critical skill for any PHP programmer. PHP provides several key functions for file input and output operations. The open function is used to open a file or a URL, specifying the mode such as read, write, or append. Once a file is opened, fclose ensures it is properly closed, preventing resource leaks. For reading data, freed allows you to retrieve content in chunks, while fwrite writes data to an open file. The fileGetContents function is a convenient way to read an entire file into a string, and FilePut Contents does the opposite by writing a string directly to a file. These functions form the backbone of file manipulation in PHP, offering flexibility for various use cases. Reading from a file in PHP can be done using multiple approaches. The fopen function with the mode R opens a file for reading, and freed allows you to read data incrementally, which is useful for large files. For simpler tasks, FileGet Contents provides a straightforward method to load an entire file into a string, making it ideal for scenarios like reading configuration files or small text documents. For example, the code content equals FileGet Contents data txt retrieves all the contents of data txt into a variable, streamlining the process of accessing file data. Writing to a file in PHP involves using fopen with the appropriate mode. The mode W allows you to write data, but it overwrites the existing content of the file, while it appends new data to the end of the file without erasing the previous content. The fwrite function is used to write data to an open file handle, and it is often paired with fopen for precise control. Alternatively, FilePut Contents offers a direct way to write a string to a file, making it a quick solution for tasks like saving user input or generating log entries. Always ensure you have the correct permissions and handle errors to avoid data loss. Before performing any file operations, it is crucial to verify the file's existence and accessibility. The fillexists function checks if a file is present, while isReadable and isWritable confirm whether the file can be read from or written to. These checks are essential to prevent runtime errors and ensure smooth execution of your code. For instance, attempting to read a non-existent file would result in an error, but validating the file's status beforehand allows you to handle such cases gracefully, improving the reliability of your applications. Error handling is a vital part of file I/O operations in PHP. When using fopen, always check if it returns false, which indicates an error such as a missing file or insufficient permissions. The errorGetLast function can retrieve details about the last error, helping you diagnose issues. For example, if fopen fails, you can use errorGetLast to get the error message and respond accordingly. Additionally, always close files with fclose after operations to free up system resources. Proper error handling ensures that your applications can recover from unexpected issues and maintain stability. Working with directories in PHP involves functions like open-dir, readdir, and close-dir, which allow you to navigate and interact with folder structures. The open-dir function opens a directory. Readdir reads its contents, and close-dir closes the directory handle. You can also create new directories using mkdir and remove empty directories with rmdir. These functions enable dynamic management of files and folders, which is particularly useful for tasks like organizing user uploads or generating reports. Understanding directory operations expands your ability to manage file systems effectively. File handling in PHP has numerous practical applications. For instance, logging application data helps track errors and user activity, making debugging easier. Reading configuration files, such as config and allows applications to store settings externally, enhancing flexibility. Storing user-generated content, like uploaded images or text, relies on file handling to manage data persistence. Additionally, processing structured data formats like CSV or XML files enables data exchange between systems. These use cases highlight the versatility of file handling in building robust and functional PHP applications. In conclusion, file handling is a cornerstone of PHP programming, enabling data persistence and interaction with external files. Mastering functions like fopen, fwrite, and filegetContents is essential for efficient file manipulation. Always prioritize error handling and validate file operations to ensure reliability. By understanding directory management and I/O techniques, you can dynamically manage files and directories, making your applications more adaptable and powerful. These skills are indispensable for any developer working with PHP. Error handling is a critical aspect of building reliable PHP applications. When writing code, it's essential to anticipate and manage unexpected situations. Without proper error handling, your application may crash, leading to poor user experiences and potential security vulnerabilities. By implementing robust error handling, you can prevent these issues, ensuring your application remains stable and user-friendly even when things go wrong. This slide will explore how to identify, manage, and resolve errors effectively in PHP. PHP categorizes errors into several types, each with distinct behaviors and implications. Notices are non-critical issues, such as referencing an undefined variable. While they don't halt execution, they can indicate potential bugs in your code. Warnings are more severe, but still non-fatal, like attempting to include a missing file. Errors, on the other hand, are critical and can stop script execution, such as syntax mistakes. Exceptions are programmable error states that you can throw and catch, allowing for more controlled error management. Understanding these types helps you address issues appropriately. Configuring error reporting is a foundational step in PHP development. The error reporting function allows you to specify which types of errors to display based on severity levels. For example, during development, you might enable all errors to catch issues early. The initSet function can adjust settings like display errors, which controls whether errors are shown directly in the browser. Similarly, loaders enables error logging to a file, which is invaluable for debugging in production environments. These settings ensure you have visibility into your application's behavior without overwhelming users with technical details. The error log function is a powerful tool for recording errors in a structured way. It allows you to send messages to a file, system log, or even a remote server. The syntax requires a message, a type indicating where to log it, and an optional destination. For instance, logging a database connection failure to a specific file helps track issues without exposing sensitive information. This function is particularly useful for monitoring and diagnosing problems in live environments where displaying errors directly is not advisable. Custom error handlers give you greater control over how errors are managed. By using setErrorHandler, you can define a function to handle errors instead of relying on PHP's default behavior. This is ideal for displaying user-friendly messages or logging errors in a specific format. For example, a custom handler might redirect users to a friendly error page or record details in a database. This approach ensures that errors are handled consistently and appropriately, enhancing both security and user experience. Exceptions in PHP provide a structured way to handle errors during program execution. Using try, catch, and finally blocks, you can isolate sections of code that might throw exceptions. When an error occurs, you can throw an exception with throw new exception, which can then be caught and handled. This allows for targeted error management, such as catching specific exception types to perform different actions. The finally block ensures cleanup code runs regardless of whether an exception is thrown, making your applications more robust. Debugging is an essential skill for any developer, as it involves identifying and resolving issues in code. Effective debugging requires a systematic approach, such as isolating the problem, reproducing the issue, and testing potential solutions. Tools like print statements, logging, and dedicated debuggers can help trace execution flow and pinpoint errors. Understanding common debugging techniques saves time and reduces frustration, making it easier to maintain and improve your applications. The vardump and printer functions are invaluable for inspecting variables, arrays, and objects. Vardump provides detailed information, including data types and values, making it useful for diagnosing complex structures. Printer, on the other hand, offers a more readable format for arrays and objects, especially when working with nested data. These functions help you understand the state of your variables at different points in your code, making it easier to identify and fix issues. Xdebug is a powerful extension that enhances PHP debugging capabilities. It allows you to set breakpoints, step through code line by line, and inspect variables in real time. Installing Xdebug involves configuring your PHP environment and enabling it in the PHP ini file. Once set up, it integrates seamlessly with IDEs like PHP Storm or VS Code, providing a visual interface for debugging. This tool is particularly useful for complex applications where tracing execution flow is challenging. Browser developer tools, such as Chrome DevTools, are essential for debugging both client-side and server-side interactions. These tools allow you to inspect network requests, view console logs, and analyze DOM elements. For example, you can monitor API calls, check for errors in the console, and debug JavaScript alongside PHP scripts. Understanding how to use these tools helps you troubleshoot issues that arise in the browser, ensuring a smooth user experience. Logging debug information is a proactive way to track application behavior and identify issues. By writing logs using functions like error log, you can record variables, execution steps, and other relevant data. For instance, logging a user ID during a critical operation helps trace issues back to specific actions. This practice is especially useful in production environments where direct error display is disabled, allowing you to diagnose problems without disrupting users. Common debugging mistakes often stem from oversight or poor practices. For example, forgetting to initialize variables can lead to unexpected behavior, while ignoring error logs in production environments leaves issues undetected. Failing to test edge cases or invalid inputs may result in unhandled errors that crash the application. Addressing these mistakes requires careful planning, thorough testing, and a proactive approach to error management. Adhering to best practices ensures your error handling and debugging efforts are effective and sustainable. Always enable error reporting during development to catch issues early, but disable it in production to avoid exposing sensitive information. Use exceptions to handle exceptional conditions rather than relying on error checks, which can clutter your code. Finally, document and test your error handling mechanisms to ensure they work as intended, reducing the risk of future problems. Mastering error handling and debugging is crucial for building stable, maintainable PHP applications. These skills not only prevent crashes, but also improve the overall user experience. By applying best practices and leveraging tools like Xdebug and browser developer tools, you can efficiently identify and resolve issues. Remember, a well-structured approach to error management and debugging saves time, reduces frustration, and leads to more reliable applications. Object-oriented programming is a way of organizing code by modeling real-world entities as objects. These objects are created from blueprints called classes, which contain both data and functions. The core idea is to bundle data and behavior together, making code more intuitive and easier to manage. The 4 key principles of OOP are encapsulation, which hides internal details, inheritance, which allows classes to share code, polymorphism, which lets objects take many forms, and abstraction, which simplifies complex systems by focusing on essential features. This approach helps developers write cleaner, more reusable code. A class acts as a template or blueprint for creating objects. Think of it like a recipe that defines what ingredients and steps are needed. An object, on the other hand, is a specific instance of that class. For example, if you have a class called car, you can create multiple car objects, each with its own unique properties. In PHP, you define a class using the class keyword, and then create an object with the new operator. This distinction between class and object is fundamental to understanding how OOP structures code. Properties are the characteristics or data stored within a class, while methods are the actions or functions that the class can perform. For instance, a car class might have a property for color and a method to start the engine. Properties can be public, private, or protected, which determines their accessibility. Methods can manipulate these properties or interact with other objects. This separation of data and behavior makes it easier to manage and update code, as changes to one part of the class don't necessarily affect others. Constructors are special methods that run automatically when an object is created. They are used to set initial values for properties, ensuring the object starts in a valid state. In PHP, the constructor is defined using the construct method. Destructors, on the other hand, are called when an object is destroyed, typically to release resources like file handles or database connections. While destructors are less commonly used, they are crucial for managing memory efficiently in resource-heavy applications. Inheritance allows a class to inherit properties and methods from another class, promoting code reuse. For example, a vehicle class might have general attributes like wheels and speed, while a car class extends vehicle to add specific features like doors. This hierarchical structure makes it easier to manage related classes and reduces redundancy. By building on existing code, developers can create more complex systems without rewriting the same logic repeatedly. Polymorphism enables objects of different classes to be treated as objects of a common superclass. This means a single interface can handle multiple data types. For instance, a method called draw might behave differently in a circle class versus a square class. This flexibility is achieved through method overriding, where a child class changes the implementation of a method from its parent. Polymorphism also works with interfaces, allowing different classes to adhere to the same contract while providing their own solutions. Encapsulation is the practice of bundling data and methods into a single unit, the class, and controlling access to internal state. using access modifiers like public, private, or protected, developers can restrict how properties and methods are accessed. For example, a private speed property ensures that external code cannot directly modify it, forcing interactions through controlled methods. This protects data integrity and makes the code more secure and easier to maintain. Static methods belong to the class itself rather than to any specific instance. They are called using the double colon operator and can be used for utility functions that don't rely on instance-specific data. For example, a static method in a car class might calculate the average fuel efficiency across all cars. Since static methods don't have access to this, they are ideal for operations that are independent of individual object states, such as logging or configuration settings. OOP in PHP is widely used to model real-world scenarios. For example, a user class might have properties like username and password, along with methods for authentication. Inheritance can simplify code by allowing a database class to be extended by specific implementations like MySQL or PostgreSQL. Interfaces like payment can define a common set of methods that different classes, such as credit card or PayPal, must implement, ensuring consistency across diverse payment systems. These examples illustrate how OOP structures complex applications into manageable components. Common mistakes in OOP include forgetting to use self when calling static methods, which can lead to errors if the method is not properly referenced. Not initializing properties in constructors can result in undefined variables, causing runtime issues. Misusing access modifiers, such as making all properties public when they should be private, can expose sensitive data and reduce code flexibility. Avoiding these pitfalls ensures cleaner, more secure, and more maintainable code. Object-oriented programming is essential for building scalable and maintainable applications. By mastering classes, objects, inheritance, and encapsulation, developers can create modular, reusable code that adapts to changing requirements. Practicing with real-world examples like user authentication systems or data models helps reinforce these concepts. As you continue learning, focus on applying OOP principles to solve problems effectively and efficiently in PHP. Object-oriented programming is a powerful approach to structuring code that allows developers to model real-world entities through classes and objects. PHP fully supports this paradigm, enabling you to create reusable and organized code. At the core of object-oriented programming are classes, which act as blueprints for creating objects, and objects, which are instances of those classes. Key concepts include properties, which store data specific to an object, methods, which define the actions an object can perform, and inheritance, which allows classes to share and extend functionality from other classes. This structure makes code more modular, easier to maintain, and scalable for complex applications. To define a class in PHP, you use the class keyword followed by the name of the class. For example, the code class car creates a new class called car. This class serves as a template for generating objects, much like a blueprint for a house. Within the class, you can declare properties to hold data and methods to define behaviors. The syntax is straightforward, with the class body enclosed in curly braces. By organizing code into classes, you can encapsulate related data and functions, making your programs more intuitive and easier to manage. Objects are instances of a class created using the new keyword. For example, my car equals new car creates an object of the car class. Each object has its own set of properties and can access the methods defined in the class. This process of instantiation allows you to generate multiple objects from a single class, each with potentially different data. For instance, one car object might represent a Toyota, while another represents a Honda. Objects are the building blocks of object-oriented programming, enabling you to interact with your code in a more intuitive, real-world manner. Properties are variables declared within a class to store data specific to an object. In the example, the car class has public properties brand and model, which can be accessed and modified directly. These properties hold the state of an object, such as the brand and model of a car. By defining properties, you can ensure that each object maintains its own unique data while sharing the same structure and behavior as other objects of the same class. Public access allows these properties to be modified from anywhere. But in practice, you might use access modifiers to control how they are accessed. Methods are functions defined within a class to describe the behaviors of an object. For instance, the start engine method in the car class might output a message like engine started when called. These methods operate on the object's properties, allowing you to perform actions or retrieve information. By encapsulating functionality within methods, you can keep your code organized and reduce redundancy. For example, a method might calculate the speed of a car or update its fuel level, all while maintaining the integrity of the object's internal state. Access modifiers determine how properties and methods can be accessed within and outside a class. The public modifier allows access from anywhere, making it ideal for methods that need to be called externally. The private modifier restricts access to within the class itself, ensuring data is protected from unintended modifications. The protected modifier allows access within the class and any subclasses, facilitating inheritance while maintaining some level of control. These modifiers are essential for encapsulation, helping you manage how data and functionality are exposed and used throughout your application. Constructors are special methods in a class that are automatically called when an object is created. In PHP, the constructor is defined using the construct method. For example, the car class's constructor takes parameters like brand and model to initialize the object's properties. This eliminates the need to manually set properties after creating an object, streamlining the initialization process. Constructors are particularly useful for ensuring that objects are in a valid state when they are first created, reducing errors and improving code efficiency. In summary, object-oriented programming in PHP provides a structured way to create reusable and maintainable code. Classes and objects allow you to model real-world entities, while properties and methods define their data and behaviors. Access modifiers and constructors enhance control over how data is accessed and initialized, making your code more robust. By leveraging these OOP principles, you can build scalable applications that are easier to manage and expand. Whether you're developing a simple website or a complex system, mastering OOP is essential for writing clean, efficient, and professional PHP code. Methods in PHP are functions that are defined within a class to carry out specific tasks. They are the building blocks of object-oriented programming, allowing objects to perform actions and interact with their properties. By encapsulating behavior within a class, methods help organize code and make it more modular. For example, a method might handle calculations, data manipulation, or even communication with external systems. The The syntax for defining a method is straightforward, using the keyword function followed by the method name and a set of parentheses, with the code block enclosed in curly braces. Access control is a key aspect of methods, as they can be declared as public, private, or protected. Public methods are accessible from anywhere. Private methods are restricted to the class itself, and protected methods allow access within the class and its subclasses. This system of access modifiers ensures that data and functionality are properly protected and used as intended. Static methods are a special type of method that belongs to the class itself rather than to any specific instance of the class. This means they can be called without creating an object of the class, using the class name followed by a double colon and the method name. For example, class name, method name. Static methods are useful for tasks that are not tied to individual objects, such as utility functions or operations that affect the entire class. However, they cannot directly access non-static properties or methods because they do not operate on an instance. This limitation ensures that static methods remain stateless and focused on class-level functionality. Common use cases include creating factory methods, performing calculations that apply to all instances, or managing shared resources. By leveraging static methods, developers can write more efficient and organized code that adheres to the principles of object-oriented design. Constructors are special methods that are automatically called when an object is created from a class. Their primary purpose is to initialize the object's properties and set up any necessary resources. In PHP, the constructor is defined using the construct method, which allows parameters to be passed during object creation. For example, when you use the new keyword to instantiate a class, the constructor runs immediately, setting default values or accepting user input. This makes it easy to ensure that every object starts in a consistent and usable state. Constructors can also be used to perform setup tasks, such as connecting to a database or loading configuration files. By customizing the constructor with parameters, developers can create flexible and dynamic objects that adapt to different scenarios. This lifecycle management is essential for building robust and reliable applications. Destructors are the counterpart to constructors, serving as the final step in an object's lifecycle. Defined using the destruct method, destructors are automatically called when an object is no longer needed or explicitly destroyed using the unset function. Their primary role is to clean up resources, such as closing files, releasing memory, or terminating database connections. This ensures that the program remains efficient and avoids memory leaks or other resource-related issues, while PHP handles memory management automatically. Destructors provide a controlled way to perform these tasks when an object is no longer in use. For example, a class that manages a file handle might use a destructor to close the file properly. Understanding how and when destructors are triggered is important for writing clean, maintainable code that adheres to best practices in resource management. Access modifiers in PHP determine how methods and properties can be accessed within a class and outside of it. The public modifier allows unrestricted access, making the method or property available from anywhere in the code. This is ideal for methods that need to be used by other classes or external code. The private modifier restricts access to the class itself, ensuring that certain data or functionality cannot be modified or used outside of the class. This helps protect the internal state of an object and prevent unintended side effects. The protected modifier strikes a balance, allowing access within the class and its subclasses, which is useful for inheritance and shared functionality. By carefully choosing access modifiers, developers can enforce encapsulation, maintain data integrity, and create more secure and maintainable code. These modifiers are fundamental to the principles of object-oriented programming and are essential for designing well-structured applications. In summary, methods are the core of object-oriented programming in PHP, defining the actions that objects can perform and encapsulating behavior within classes. Constructors and destructors play critical roles in managing the creation and destruction of objects, ensuring proper initialization and resource cleanup. Access modifiers provide a powerful mechanism for controlling how class members are accessed, promoting encapsulation and data integrity. Together, these concepts form the foundation of effective object-oriented design, enabling developers to write reusable, maintainable, and efficient code. Mastering methods, constructors, destructors, and access modifiers is essential for anyone looking to build robust PHP applications and leverage the full potential of object-oriented programming. By applying these principles, programmers can create structured, scalable, and secure software solutions. Inheritance is a core object-oriented programming concept that allows classes to inherit properties and methods from other classes. This means that you can create a new class based on an existing one, which can save time and reduce code duplication. In PHP, this is achieved through a mechanism called single inheritance, which means that a class can only extend one parent class. This helps keep the code structure simple and avoids the complexities that come with multiple inheritance. To create a subclass in PHP, we use the extends keyword, which establishes a parent-child relationship between classes. This foundational concept is essential for building scalable and maintainable applications. The key concepts of inheritance include the superclass, the subclass, and the inheritance hierarchy. The superclass, also known as the base class, is the original class that provides the properties and methods that other classes can inherit. The subclass, or child class, is the class that inherits from the superclass, allowing it to reuse and extend the functionality of the parent. These relationships form an inheritance hierarchy, which organizes classes in a tree-like structure. This hierarchy enables developers to build complex systems by logically grouping related classes and promoting code reuse across different levels of the hierarchy. Let me walk through an example of inheritance in PHP. Here, we have an animal class with a speak method that outputs animal sound. The dog class extends animal, meaning it inherits all the properties and methods of animal. However, the dog class redefines the speak method to output woof instead. This process of redefining a method from the superclass is called method overriding. Subclasses can not only inherit, but also modify or enhance the behavior of their parent classes, allowing for more flexible and specific implementations. This example demonstrates how inheritance enables customization while maintaining a shared foundation. Access modifiers determine the visibility of class members, such as properties and methods. Public access means that a member can be accessed from anywhere, including outside the class. Private access restricts a member to the class in which it is defined, ensuring that it cannot be modified or used by subclasses or external code. Protected access allows a member to be accessed within the class and its subclasses, making it ideal for shared functionality that should not be exposed publicly. Understanding these modifiers is crucial for controlling how data and methods are used, which helps prevent unintended side effects and improves code security. Polymorphism is another fundamental concept in object-oriented programming that allows objects of different classes to be treated as objects of a common superclass. This means that a single interface can be used to represent multiple data types, making code more versatile and easier to manage. Polymorphism is achieved through method overriding, where a subclass provides a specific implementation of a method defined in its superclass. Additionally, PHP 8 introduces support for method overloading through named parameters, which allows functions to accept different argument types and configurations while maintaining a consistent interface. This flexibility enhances the ability to write reusable and adaptable code. Method overriding is a key aspect of polymorphism, where a subclass provides its own implementation of a method that already exists in its superclass. For instance, the animal class might have a make sound method, but the cat class can override this method to produce a meow sound. When a method is called on an object, PHP automatically uses the implementation from the object's actual class, not the superclass. This behavior allows for dynamic and context-specific functionality, making it easier to create diverse and specialized classes while maintaining a unified interface. Abstract classes and methods are used to define a blueprint for other classes. An abstract class cannot be instantiated on its own and must be extended by a subclass. It can contain both abstract methods, which are declared without any implementation, and concrete methods, which provide a default behavior. For example, an abstract shape class might declare an area method without defining it, requiring subclasses like circle to implement the specific calculation. This approach enforces a consistent structure while allowing flexibility in how each subclass fulfills its responsibilities. Abstract classes are particularly useful for defining common behavior and ensuring that subclasses adhere to a specific contract. Interfaces are another way to define a contract for classes to follow. Unlike abstract classes, interfaces cannot contain any implementation details and only declare method signatures. All methods in an interface are public by default, meaning they must be implemented by any class that adopts the interface. For example, a drawable interface might require a draw method, which a square class can implement to define its specific drawing logic. Interfaces are ideal for defining a set of behaviors that multiple unrelated classes can share, promoting consistency and enabling a form of multiple inheritance in PHP. This makes it easier to create modular and interchangeable components. The benefits of inheritance and polymorphism are significant for building robust applications. Inheritance promotes code reuse by allowing classes to share and extend existing functionality, reducing redundancy and improving efficiency. Polymorphism enhances scalability by enabling objects to take on multiple forms, which simplifies the management of complex systems. Together, these concepts make code more maintainable, as changes to a superclass automatically propagate to all subclasses. They also allow for more flexible and extensible designs, making it easier to adapt to changing requirements and add new features without disrupting existing code. While inheritance and polymorphism are powerful, they come with potential pitfalls that should be avoided. Overusing inheritance can lead to overly complex hierarchies, making the code harder to understand and maintain. Tight coupling between classes, where one class depends too heavily on another, can reduce flexibility and increase the risk of errors. Misunderstanding access modifiers can result in unintended access to private or protected members, leading to unexpected behavior. To mitigate these issues, it is important to design classes with clear responsibilities. Favor composition over inheritance when appropriate, and carefully manage access levels to ensure code integrity. In summary, inheritance and polymorphism are essential for creating scalable and maintainable object-oriented systems in PHP. By understanding how to extend classes, override methods, and use interfaces, developers can build flexible and reusable code. Practicing these concepts through hands-on examples and focusing on clean design principles will help avoid common mistakes and improve overall code quality. As you continue your PHP training, remember that effective use of inheritance and polymorphism can significantly enhance the structure and functionality of your applications. Static methods and properties are unique to the class itself rather than any individual instance. This means that they are not tied to a specific object, but are shared across all instances of the class. To declare a static method or property, we use the static keyword. This feature is particularly useful when we need to have data or functions that are common to all objects of a class, such as a counter that tracks the number of instances created, or a utility function that performs a general task. Declaring static members in PHP involves using the static keyword with either a method or a property. For a static method, the syntax is public static function followed by the method name and its code block. Similarly, a static property is declared with public static followed by the property name. For example, consider a class called myClass with a static property count initialized to 0 and a static method increment that increases this count. The method uses self $count to access the static property, which is essential because static methods do not have access to instance variables. To access static members, we use the class name followed by the double colon and the property or method name. For instance, my class $count allows us to retrieve the value of the static property. Inside the class, we can refer to static members using self or static, which helps in maintaining the correct context. It's important to note that inside a static method, we cannot use this because there is no instance of the class available. This restriction ensures that static methods operate independently of any object state. Static methods are commonly used for utility functions that perform specific tasks without relying on instance data. Examples include mathematical operations like adding two numbers or formatting dates. Another common use is factory methods, which are responsible for creating instances of a class. For example, a math class might have a static add method that takes two parameters and returns their sum. These methods are called directly on the class rather than on an object, making them convenient for general purpose functions. Static properties are ideal for storing data that is shared among all instances of a class. An example is a connection count in a database class, which tracks how many times the connect method has been called. Additionally, constants can be declared as static to hold fixed values, such as a maximum number of users allowed. By using static properties, we ensure that all instances of the class access the same data, which is useful for maintaining consistency across the application. The advantages of using static methods and properties include improved memory efficiency, since they are loaded once and shared among all instances. They also provide global access, allowing any part of the application to use them without creating an object. However, it's important to follow best practices. Static methods should be used for utility functions and constants, while avoiding their use for stateful data that changes frequently. Overusing static methods can lead to issues with testability, so it's often better to use dependency injection, which allows for more flexible and maintainable code. In summary, static methods and properties are powerful tools for sharing functionality and data across all instances of a class. Understanding their scope and limitations is crucial for effective use. By applying them judiciously, we can create clean, efficient, and maintainable code that leverages the benefits of static members without falling into common pitfalls. Databases are essential for storing and retrieving web application data. Whether you are building a simple contact form or a complex e-commerce platform, databases serve as the backbone for managing information. PHP provides built-in functions to interact with MySQL databases, allowing developers to perform tasks like connecting, querying, and manipulating data. Key functions include miscli connect, which establishes a connection to the database, miscli query, which executes SQL commands, and miscli fetch a sock, which retrieves results from a query. MySQL is a relational database management system, meaning it organizes data into tables with defined relationships, making it efficient for structured data storage and retrieval. Establishing a connection to a MySQL database is the first step in any PHP application that interacts with a database. The miscli connect function requires 4 parameters: the host, username, password, and database name. For example, the code con equals miscli connect localhost root. MyDB creates a connection to a local database called MyDB. It is crucial to check for connection errors using if con die connection failed, miscli connect error, to ensure the application does not proceed with a faulty connection. After completing database operations, always close the connection with miscli close $con to free up resources and prevent potential leaks. Creating a database and table is fundamental to organizing data in MySQL. To create a database, you can use the SQL command create database MyDB, which initializes a new database. Once the database is created, you can define tables to store specific types of data. For instance, a user's table might include columns for id, name, and email. The SQL statement, create table users, id, int, auto, and crment, primary key, name varchar 50, email varchar 100, sets up a table with an auto-incrementing primary key, a name field that can hold up to 50 characters, and an email field that can hold up to 100 characters, ensuring proper data types and constraints, such as primary keys and unique identifiers, is critical for maintaining data integrity and preventing inconsistencies. Inserting data into a MySQL database involves using the insert into SQL command. For example, the statement insert into user's name, email values John at example.com, adds a new record to the user's table. In PHP, you can construct the SQL query dynamically using variables, such as SQL equals, insert into user's name, email values name, email. This query is then executed with miscli query $con SQL. However, it is vital to validate and sanitize user input before insertion to prevent security vulnerabilities like SQL injection. Techniques such as filtering input data and using prepared statements can significantly enhance the safety of your application. Retrieving data from a MySQL database is typically done using the select SQL command. For example, the query select from users fetches all records from the users table. In PHP, this query is executed with miscli query $con SQL, which returns a result set. To process the data, you can use miscli fetch a sock result in a loop, which fetches each row as an associative array. For instance, while row miscli fetch a sock result, echo row name displays the name of each user. This method allows developers to dynamically generate web pages based on database content, making it a cornerstone of interactive web applications. Updating and deleting data in a MySQL database requires careful handling to avoid unintended consequences. The update command modifies existing records, such as changing a user's email address with update users set email equals new at example.com, where id equals 1. The delete command removes records, like deleting a user with delete from users, where id equals 1. Both operations must include a where clause to target specific rows, as omitting it can result in deleting all data in a table. After executing these commands, using miscly affected rows, $con provides feedback on how many records were modified or deleted, helping developers verify the success of their operations. Security is a critical aspect of working with MySQL and PHP. One of the most common vulnerabilities is SQL injection, where malicious input can manipulate SQL queries to access or alter data. To prevent this, developers should use prepared statements, which separate SQL code from user input. For example, miscly prepared $con, insert into user's name, email values, creates a parameterized query, and miscly stmt bind param binds values to placeholders. This approach ensures that user input is treated as data, not executable code. Additionally, avoid hard-coding database credentials in scripts. Instead, use configuration files or environment variables to store sensitive information securely. Integrating MySQL with PHP is essential for building dynamic and data-driven web applications. Mastering the fundamentals of connecting to a database, executing queries, and handling data is the first step toward creating robust applications. Beyond the basics, developers should focus on security practices like prepared statements and input validation to protect their applications from common threats. Practicing with real-world scenarios, such as building a login system or a blog platform, reinforces these concepts and helps identify potential issues. For those looking to advance, exploring topics like object relational mapping, ORM, or database normalization can further optimize data management and application performance. Understanding the role of databases in web applications is fundamental to building dynamic and interactive websites. Databases serve as the central storage for data, allowing applications to store, retrieve, and manage information efficiently. When working with PHP, connecting to a database enables the creation of dynamic web pages that can respond to user input, display real-time data, and maintain persistent information across sessions. The objectives of this session include learning how to establish a connection between PHP and a database, understanding how to handle errors that may occur during this process, and adopting best practices to ensure secure and efficient database interactions. These skills are essential for any developer aiming to build robust web applications. Connecting PHP to a database is crucial for several reasons. First, it allows the secure storage of user data, such as login credentials, personal information, and preferences, ensuring that this information is protected from unauthorized access. Second, databases enable the creation of dynamic web pages that can display real-time data, such as user-generated content, product listings, or live updates. Third, database integration facilitates user authentication, allowing users to log in and access personalized content. It also supports data manipulation, such as adding, updating, or deleting records, and enables reporting features by aggregating and analyzing stored data. These capabilities make databases an indispensable part of modern web development. PHP provides two primary extensions for interacting with databases: MySQLi and PDO. MySQLi, short for MySQL Improved, is a native PHP extension specifically designed for working with MySQL databases. It offers a wide range of functions for database operations and is optimized for performance. On the other hand, PDO, which stands for PHP Data Objects, is a database-agnostic extension that supports multiple database systems, including MySQL, PostgreSQL, and SQLite. This flexibility makes PDO a versatile choice for projects that may need to switch databases in the future. The choice between these extensions depends on the project's requirements, such as the need for high performance, cross-database compatibility, or advanced security features. Each extension has its strengths, and understanding their differences helps in making informed decisions. Establishing a connection to a MySQL database in PHP involves using the misclick function. This function requires 4 parameters: the host name, which is typically localhost for local servers, the username, often root for development environments, the password, which should be kept secure, and the database name, which is the specific database you want to connect to. For example, the code con misclick connect localhost, user password DB name creates a connection object. After attempting to connect, it is essential to verify the success of the operation. This can be done by checking for errors using misclick-connector-no, which returns a numeric error code, or by testing if the connection object is null. These checks help identify and resolve issues before proceeding with database operations. When using PDO to connect to a MySQL database, the process involves initializing a PDO object with a data source name, or DSN. The DSN specifies the database type, host, and database name, followed by the username and password. For instance, the code PDO equals new PDO MySQL, host equals localhost, DB name equals DB name. User password creates a connection. To enhance error handling, it is recommended to set the error mode to exception, which can be done using set attribute PDO, a true mode PDO, error mode exception. This configuration ensures that any database-related errors throw exceptions, making it easier to trace and debug issues during development. PDO's flexibility and robust error handling make it a powerful tool for database interactions. Effective error handling is critical when working with database connections in PHP. Developers should always check for connection failures by using functions like misclickConnectorIno or examining the connection object. Displaying meaningful error messages helps in identifying the root cause of issues, such as incorrect credentials or network problems. However, in production environments, it is essential to avoid exposing sensitive details, such as exact error messages or database structure, to prevent potential security risks. Instead, developers should log errors securely and provide generic messages to users. This approach ensures that troubleshooting remains efficient while maintaining the integrity and security of the application. Security is a top priority when connecting PHP to a database. One of the most effective ways to prevent SQL injection attacks is by using prepared statements, which separate SQL code from user input. This ensures that user data is treated as data, not executable code. Storing database credentials securely is another critical practice. Instead of hard-coding them in scripts, developers should use environment variables or configuration files like env, which are not accessible to the public. Additionally, limiting the permissions of the database user to the minimum required for the application reduces the potential impact of a security breach. These measures collectively enhance the security posture of the application and protect sensitive data from unauthorized access. Properly closing a database connection is an essential step in resource management. In MySQLi, this can be done using the misclose function, which takes the connection object as a parameter. For PDO, setting the connection object to null, such as PDO equals null, effectively closes the connection. Closing connections after use ensures that resources are freed up, preventing memory leaks and improving the performance of the application. It is also important to ensure that connections are closed in all scenarios, including when errors occur or when scripts terminate unexpectedly. This practice contributes to the overall stability and efficiency of the application. Connecting PHP to a database is a foundational skill for building dynamic and interactive web applications. Choosing the right extension, whether MySQLi for MySQL-specific tasks or PDO for cross-database flexibility, depends on the project's requirements and constraints. Prioritizing security, such as using prepared statements and secure credential storage, is vital to protect against common vulnerabilities. Effective error handling ensures that issues are identified and resolved promptly, while proper resource management prevents leaks and improves performance. By following these best practices, developers can create robust, secure, and efficient applications that leverage the power of databases to deliver dynamic user experiences. Today, we will explore the role of SQL in interacting with databases and how PHP connects to and queries databases. SQL is essential for managing and retrieving data, and PHP provides tools to integrate with relational databases like MySQL. We will also examine key SQL commands such as select, insert, update, and delete, and how they are implemented in PHP to perform database operations. Understanding these concepts is crucial for building dynamic web applications that rely on data storage and retrieval. To connect to a MySQL database using PHP, you can use either the misclose function or the PDO extension. Both methods have their advantages, but it is vital to store database credentials securely. Avoid hard-coding usernames and passwords directly in your code. Instead, use environment variables or configuration files that are not accessible to the public. For example, the misclose function takes parameters like the host, username, password, and database name to establish a connection. Always ensure your connection is properly configured to prevent unauthorized access. In PHP, executing basic SQL queries involves using functions like query to send commands to the database. The select statement retrieves data, insert adds new records, update modifies existing entries, and delete removes data. Each of these commands must be structured correctly in SQL syntax. For instance, a select query might fetch all rows from a table, while an insert would add a new row with specified values. Understanding how to construct and execute these queries is fundamental for interacting with databases effectively. Once a query is executed, you need to retrieve the results. The misclife function allows you to fetch rows as associative arrays, which makes it easier to access data by column names. You can loop through the results using while or for each loops to process each row. For example, a while loop might iterate over the results and display them on a web page. This process is essential for presenting dynamic data to users and handling large data sets efficiently. Security is a critical concern when working with databases. SQL injection occurs when malicious users inject harmful code into queries, potentially compromising your database. This risk arises when user input is not properly sanitized or validated. For instance, directly embedding user-supplied data into SQL statements can allow attackers to alter queries. A vulnerable example might involve using GET parameters without filtering, which could lead to unauthorized data access or modifications. Always avoid concatenating user input directly into SQL commands. To prevent SQL injection, use prepared statements. This method separates SQL code from data, ensuring that user input is treated as values rather than executable code. With miscliprepare, you can create a statement template and bind parameters to it. For example, a prepared statement might include placeholders for values, which are then filled in securely. This approach not only enhances security, but also improves performance by allowing the database to reuse query plans. Always use parameterized queries to protect your application. Proper error handling is essential when working with database queries. Functions like misclickOnicTerror and misclearer help identify issues during connection or query execution. For example, checking if a connection fails and displaying an appropriate message can prevent application crashes. In production environments, avoid showing raw error messages to users. Instead, log errors to a file for debugging. This practice maintains security and ensures a better user experience by hiding technical details from potential attackers. Advanced SQL techniques enable more complex data manipulation. Join operations allow you to combine data from multiple tables based on related columns, such as matching user IDs with order details. The where clause filters results to meet specific conditions, while order by sorts data in ascending or descending order. Limit restricts the number of rows returned, which is useful for pagination. These techniques are vital for creating efficient and powerful queries that retrieve exactly the data you need. Adhering to best practices ensures your PHP and SQL code is secure and maintainable. Always sanitize and validate user input to prevent vulnerabilities like SQL injection. For high-traffic applications, consider using persistent connections to reduce the overhead of establishing new database links. Never store database credentials in version control systems like GitHub. Instead, use environment variables or encrypted configuration files. These practices contribute to a robust and scalable application architecture. In summary, mastering SQL in PHP involves understanding how to connect to databases, execute queries, and handle results securely. Prioritizing security through prepared statements and input validation protects your application from common threats. By following best practices, you can create reliable, maintainable code that efficiently manages data. Apply these concepts to build dynamic web applications that are both functional and secure. SQL is a powerful language designed to communicate with databases, allowing you to store, retrieve, and manage data efficiently. In the context of PHP, developers use specific tools like PDO and MySQLi to interact with databases seamlessly. These extensions provide functions that make it easier to execute SQL commands while maintaining a clean separation between code and data. When you handle SQL statements properly, you not only improve the performance of your applications, but also protect them from potential security threats, such as unauthorized access or data corruption. This foundation is essential for building robust and reliable web applications. Preparing SQL statements is a critical step in ensuring both security and efficiency. By using methods like PDO prepare, or misclip-prepare, you create a template for your SQL queries that separates the structure of the command from the data it processes. This separation is vital because it prevents malicious users from injecting harmful code into your queries, a common attack vector known as SQL injection. Additionally, prepared statements allow you to reuse the same query structure multiple times with different data inputs, which can significantly reduce the overhead of parsing and compiling queries repeatedly. This approach is especially beneficial in scenarios where the same operation is performed with varying parameters. Once a SQL statement is prepared, the next step is to bind parameters to the placeholders in the query. This process involves using functions like bind param or bind value to associate specific variables with the placeholders, such as username or binding parameters, ensures that the data types are correctly interpreted by the database, which helps avoid errors and maintains data integrity. For example, if a placeholder is expecting an integer, binding a string value could lead to unexpected results. By explicitly defining the data types, you add another layer of control and reliability to your database interactions, making your code more predictable and easier to debug. After preparing and binding parameters, the next step is to execute the prepared statement. This is done using the execute method, which runs the query with the provided data. When you call execute, you can pass an array of values that correspond to the placeholders in the query, allowing for dynamic data insertion or modification. This method is not only efficient, but also enhances security by ensuring that user input is never directly embedded into the SQL command. The execution process is designed to handle a wide range of data scenarios, making it a versatile tool for developers working with databases in PHP. Retrieving results from a SQL query is a fundamental aspect of database interaction. For select statements, functions like fetch and fetchall are used to retrieve data from the database. The fetch method retrieves one row at a time, which is useful for processing large datasets incrementally, while fetchall returns all results at once, making it suitable for smaller queries. For non-select operations such as insert, update, or delete, it's important to check the return value of the execute method to determine if the operation was successful. Always validating and and sanitizing the output before displaying it to users is crucial to prevent issues like cross-site scripting or data leakage, ensuring a safer user experience. Security should always be a top priority when working with SQL and PHP. One of the most common mistakes is directly concatenating user input into SQL queries, which can expose your application to SQL injection attacks. These attacks occur when an attacker manipulates the input to alter the intended SQL command, potentially leading to data breaches or unauthorized access. By using prepared statements and parameterized queries, you create a barrier that prevents such attacks. Every piece of data that comes from an external source, such as a form submission or an API request, should be treated as untrusted and processed through these secure methods. This practice not only safeguards your database, but also aligns with industry standards for secure coding. In summary, mastering the preparation and execution of SQL statements in PHP is essential for building secure and efficient applications. By leveraging prepared statements and parameterized queries, you eliminate the risks associated with direct SQL injection and ensure that your code is both maintainable and scalable. Always prioritize error handling and result validation to catch potential issues early and provide a more reliable user experience. These practices are not just technical necessities, but also foundational elements of modern web development, enabling developers to create applications that are both powerful and safe. Security is a fundamental pillar of any robust PHP application. Without proper security measures, user data can be compromised, leading to loss of trust, financial damage, or legal consequences. It is not just about protecting the system, but also safeguarding the privacy and rights of users. Common vulnerabilities such as SQL injection, cross-site scripting, and insecure authentication create entry points for malicious actors. For instance, SQL injection allows attackers to manipulate database queries, while XSS can inject harmful scripts into web pages viewed by others. Insecure authentication practices like weak password storage or lack of multi-factor verification can lead to unauthorized access. As developers, it is our responsibility to adopt secure coding habits, stay informed about emerging threats, and implement proactive safeguards to ensure our applications remain resilient against attacks. SQL injection is a critical security flaw that occurs when an attacker inserts malicious SQL code into input fields, such as login forms or search bars. This happens because the application fails to properly validate or sanitize user input. For example, if a user enters a username or password that contains SQL commands, the application might execute those commands instead of treating them as regular input. This can lead to unauthorized access to sensitive data, such as customer records or system credentials. Attackers can exploit this vulnerability to manipulate databases, steal information, or even delete critical data. The key to understanding SQL injection lies in recognizing how untrusted input can be transformed into executable code, highlighting the importance of securing all points of user interaction. To execute an SQL injection attack, an attacker typically targets input points where user data is processed by the application. These can include form fields, URL parameters, or cookies. For example, a login form might accept a username and password, but if the application directly concatenates these inputs into a SQL query, an attacker can inject malicious code. Imagine a scenario where an attacker inputs a username like admin and a password like anything. The resulting SQL query might become select from users, where username equals admin and password equals anything. The comments out the rest of the query, allowing the attacker to bypass authentication. This demonstrates how even a simple oversight in input handling can create significant security risks. One of the most common examples of SQL injection is bypassing login screens. By entering a username and password that manipulate the SQL query, attackers can gain unauthorized access. For instance, using the input or 1 equals 1 in both fields might result in a query that always evaluates to true, effectively logging the attacker in as an admin. Another attack vector involves extracting sensitive data. An attacker could inject a query to retrieve user emails or passwords, which can then be used for further exploitation. Additionally, SQL injection can be used to delete or alter database records, causing data corruption or loss. These examples underscore the need for rigorous input validation and secure coding practices to prevent such attacks. Preventing SQL injection requires a combination of techniques and best practices. One of the most effective methods is using prepared statements, which separate SQL code from user input. With tools like PDO or MySQLi, developers can parameterize queries, ensuring that user data is treated as data and not executable code. Input validation is another crucial step. By defining strict rules for what constitutes valid input, developers can block malicious payloads. For example, rejecting special characters in a username field can mitigate injection risks. Avoiding dynamic SQL concatenation is also essential. Instead, developers should use stored procedures or ORM frameworks that handle database interactions securely. These measures collectively reduce the attack surface and protect applications from exploitation. Adopting secure coding practices is essential for maintaining the integrity of PHP applications. A key recommendation is to always use prepared statements for database interactions, as they prevent malicious code from being executed. Input validation should be comprehensive, checking for both format and content, while output escaping ensures that data displayed to users does not contain harmful scripts. For example, using functions like HTML special chars can neutralize potential XSS threats. Additionally, keeping PHP and its libraries up to date is vital, as updates often include security patches for known vulnerabilities. Developers should also implement least privilege principles, limiting access to sensitive operations and data. By integrating these practices into the development lifecycle, teams can significantly reduce the risk of security breaches. In conclusion, security is not an optional feature, but a core requirement for any PHP application. SQL injection remains one of the most prevalent threats, but with the right strategies, it can be effectively mitigated. By prioritizing secure coding practices, staying vigilant about input handling, and continuously updating systems, developers can build applications that are resilient to attacks. Proactive measures, such as regular security audits and penetration testing, further ensure that vulnerabilities are identified and addressed before they can be exploited. Ultimately, a commitment to security fosters trust, protects user data, and ensures the long-term success of PHP-based projects. Security is a critical aspect of developing PHP applications, as it protects both the application and its users from malicious attacks. Without proper security measures, your code can become a target for various threats. Common threats include SQL injection, where attackers manipulate database queries to access or alter data, and cross-site scripting, which allows malicious scripts to run in a user's browser. Another risk is cross-site request forgery, which tricks users into performing unintended actions, and insecure file uploads that can lead to executing harmful code. The objectives of this presentation are to help you identify these vulnerabilities, understand their impact, and implement preventive measures to build more secure applications. Preventing SQL injection is essential to protect your database from unauthorized access. One of the most effective methods is using prepared statements with either the PHP data, objects extension, or MySQLi. These statements separate SQL code from user input, making it impossible for attackers to inject malicious queries. Avoid concatenating user inputs directly into SQL queries, as this creates a vulnerability. Instead, always validate and sanitize all user inputs. For example, if a user enters a username, ensure it matches expected patterns and does not contain harmful characters. Combining these practices significantly reduces the risk of database breaches. Cross-site scripting, or XSS, occurs when an attacker injects malicious scripts into web pages viewed by other users. To prevent this, always escape user-generated content before displaying it in HTML. Functions like HTML special chars or HTML entities convert special characters into their corresponding HTML entities, preventing scripts from executing. For instance, if a user submits a comment with a script tag, escaping ensures it appears as text rather than active code. Additionally, implementing content security policy headers adds another layer of protection by specifying which sources of content are allowed, further limiting the impact of potential XSS attacks. Cross-site request forgery, or CSRF, exploits the trust a user has in a website to perform actions without their knowledge. To defend against this, use anti-CSRF tokens in forms. These tokens are unique values generated for each user session and verified when the form is submitted. This ensures the request originates from the intended user. Checking the referrer header can also help identify the source of a request, though it is not foolproof as it can be manipulated. Another strategy is setting the same site attribute for cookies, which restricts how cookies are sent with cross-site requests, reducing the risk of CSRF attacks. Secure file uploads require careful handling to prevent malicious files from being executed. First, validate file types and extensions on the server side, as client-side checks can be bypassed. For example, a file with a PHP extension should not be allowed if it is not intended to be a PHP script. Store uploaded files outside the web root directory to prevent direct access via a URL. Additionally, use unique file names for each upload to avoid overwriting existing files, which could lead to data loss or security risks. These steps ensure that only safe and authorized files are processed by your application. Effective session management is crucial to maintaining user authentication security. After a user logs in, regenerate the session ID to prevent session fixation attacks, where an attacker uses a previously generated session ID to impersonate a user. Use secure cookies with the HTTP only and secure flags to prevent access via JavaScript and ensure cookies are only transmitted over HTTPS. Set session timeouts to limit the duration of inactivity, reducing the window of opportunity for session hijacking. These practices help protect user sessions from unauthorized access. Input validation and sanitization are fundamental to securing PHP applications. Use PHP filters like filtervar to check if input data meets specific criteria, such as valid email formats or numeric values. Reject any input that does not conform to expected patterns, as this helps prevent malicious data from being processed. Relying solely on client-side validation is risky because it can be disabled or bypassed. Always perform server-side validation to ensure data integrity and prevent attacks that exploit untrusted input. Proactive security measures are essential to minimize vulnerabilities in PHP applications. By combining validation, sanitization, and secure coding practices, you can create a robust defense against common threats. Stay updated with the latest PHP security patches and best practices, as new vulnerabilities are discovered regularly. Security is not a one-time task, but an ongoing process that requires continuous attention and improvement. Implementing these strategies ensure ensures your applications remain secure and resilient against evolving threats. PHP provides built-in classes and functions for working with dates and times. These tools are essential for handling tasks like scheduling, logging, and user input validation. The key classes include datetime, which represents a specific date and time, date interval, which defines a period of time, and date period, which creates a series of dates based on a start date, interval, and end date. Common tasks involve formatting dates for display, parsing user input, calculating the difference between two dates, and managing time zones to ensure accuracy across different regions. To create a datetime object, you can use the new datetime constructor. This initializes a date and time object with the current date and time. For example, date equals new date time will store the current date and time. You can also specify a time zone by passing a time zone identifier, such as date equals new date time Europe / London, which sets the time zone to London. Additionally, the create from format method allows you to parse a date string using a specific format, like date equals date time. Create from format EMD 2020-31015, which converts the string into a datetime object. The format method is used to output a date and time in a specific format. Common format characters include Y for the 4-digit year, M for the 2-digit month, D for the 2-digit day, H for the hour in 24-hour format, I for minutes, and S for seconds. For instance, date format EMDH, IS, will produce a string like 2023-1015-1430-00. Understanding these format characters is crucial for generating human-readable or machine-parsable date strings. You can also combine them in custom formats to suit specific requirements, such as including the day of the week or time zone information. Managing time zones is critical when working with dates and times across different regions. The set time zone method allows you to change the time zone of a date-time object. For example, date set time zone new date time zone America / New York adjusts the date and time to New York's time zone. To explore available time zones, you can use date time zone list identifiers, which returns an array of valid time zone identifiers. This is particularly useful when building applications that need to handle user inputs from multiple geographic locations. The date interval class represents a duration or a period of time. You can create an interval using a string format, such as interval equals new date interval 1D, which represents 1 day. Intervals are commonly used to add or subtract time from a date-time object. The add method increases the date and time by the interval, while the sub method decreases it. For example, date add $interval would add 1 day to the current date. This is helpful for tasks like calculating deadlines, scheduling events, or generating recurring dates. The diff method calculates the difference between two date-time objects and returns a date interval object. For instance, difference equals date 1 diff $date 2 computes the interval between date 1 and date 2. You can then access properties like Y for years, M for months, D for days, H for hours, I for minutes, and S for seconds. This is useful for determining how much time has passed between events, or how far in the future an event occurs. It's important to note that the diff method accounts for varying month lengths and leap years automatically. The strtotime function converts a date string into a Unix timestamp, which is the number of seconds since January 1, 1970. For example, strtotime 2023-10-15 returns the timestamp for that date. The date function then formats a timestamp into a readable string. Combining these, dateemd, strtotime 2023-10-15 would output 2023-10-15. While these functions are convenient for quick conversions, they are less flexible than the date-time class for complex operations like time zone handling or interval calculations. PHP offers several built-in functions for date and time manipulation. The time function returns the current Unix timestamp, which is useful for tracking the current time in seconds. The mktime function creates a timestamp from individual date components, such as year, month, day, hour, minute, and second. For example, mktime 14:30:0:10:15 2023 generates the timestamp for October 15, 2023 at 2:30 p.m. The date default time zone set function sets the default time zone for the entire script, ensuring consistency when working with date and time functions. Handling time zones and daylight saving time requires careful consideration. The date time zone class manages time zone specific rules, including daylight saving time changes. For example, a date in New York might shift forward or backward depending on the time of year, It's important to validate user inputs for time zones and dates to prevent errors caused by ambiguous or invalid values. Always test your code with different time zones and daylight saving scenarios to ensure reliability. When working with dates and times in PHP, it's best to use date-time objects for their robustness and flexibility. Always specify time zones to avoid ambiguity, especially when dealing with user inputs from different regions. Validate and sanitize date and time inputs to prevent errors or security issues. Rely on built-in functions like date time, date interval, and date period for consistent and reliable results. Avoid using outdated functions like str_time for complex operations. And remember that proper time zone management is essential for accurate date and time handling. Regular expressions are powerful tools used to match, search, or manipulate strings based on specific patterns. They are essential for tasks like validating user input, extracting information from text, or replacing parts of a string. For example, you can use them to check if an email address follows a correct format, or to find all numbers in a paragraph. In PHP, these operations are supported through the PCRE library, which stands for Perl Compatible Regular Expressions. This library provides a robust set of functions that allow developers to work with complex string manipulation tasks efficiently. PHP offers several built-in functions for working with regular expressions. The first is prigmatch, which checks if a pattern exists in a string and returns a Boolean value. If you need to find all occurrences of a pattern, the prigmatchal function is the right choice. For replacing parts of a string that match a pattern, the progreplace function comes in handy. Lastly, the prigsplit function allows you to split a string into an array based on a regex pattern. These functions are fundamental for handling text processing tasks in PHP, making it easier to work with dynamic data. To create a regular expression, you start by enclosing the pattern in delimiters, which are typically forward slashes. For example, pattern. Special characters like a dot or an asterisk have specific meanings in regex, so they need to be handled carefully. If you want to match a literal dot, you must escape it using a backslash. Character classes, denoted by square brackets, allow you to define a set of characters to match. For instance, EU matches any vowel, while 09 matches digits. These elements form the foundation of building more complex patterns. Quantifiers in regular expressions help control how many times a character or group appears. The dot matches any single character, while the asterisk allows for 0 or more of the preceding element. The plus sign requires 1 or more occurrences, and the question mark indicates 0 or 1. For more precise control, you can use curly braces to specify a range of repetitions. For example, 35 means the preceding element must appear 3 to 5 times. These tools enable you to create flexible and efficient patterns for various applications. Regex modifiers and flags adjust the behavior of patterns during matching. The I flag makes the match case insensitive, which is useful for ignoring uppercase and lowercase differences. The M flag treats the input as multiple lines, allowing anchors like and dollar to match at line breaks. The S flag lets the dot match new line characters, which is helpful when working with multi-line text. Lastly, the X flag ignores white space and comments within the pattern, making complex expressions more readable. These modifiers provide additional flexibility when crafting regex. Let me walk through some practical examples of how regex can be used in PHP. For email validation, a pattern like /w plus at az plus backslash az2 $3 for a valid format. The pragmatual function can extract numbers from a string by matching \d plus and storing the results. When replacing URLs in a text, the progreplace function can turn links into clickable hyperlinks by using a pattern like HTTPS ////s plus and replacing it with an anchor tag. These examples demonstrate how regex simplifies tasks that would otherwise require complex code. Regular expressions are widely used in real-world scenarios. In form validation, they ensure that user input meets specific criteria, such as password strength or phone number formats. For data scraping, regex helps extract relevant information from HTML or other structured text. Search and replace operations in large files become manageable with regex, as does parsing log files or configuration files to find specific entries. These use cases highlight the versatility of regex in handling diverse text processing challenges. To use regex effectively, follow best practices that enhance readability and security. Always test your patterns using online tools like regex 1011 one COM to catch errors early. Avoid creating overly complex patterns that are hard to maintain. Use the progressed error function to handle any issues that arise during execution. When working with user input, escape special characters to prevent vulnerabilities like injection attacks. These practices ensure that your regex code is both functional and secure. In conclusion, regular expressions are indispensable tools for string manipulation in PHP. Mastering their syntax and functions allows developers to handle text processing tasks efficiently. Through practice with real-world examples, you can improve your proficiency and confidence in using regex. Always remember to validate and sanitize inputs when using regex to maintain security and reliability in your applications. Arrays in PHP are a powerful tool for storing multiple values within a single variable, allowing developers to organize and manage data efficiently. These structures can hold a wide variety of data types, including integers, strings, objects, and even other arrays. This flexibility makes arrays essential for tasks ranging from simple data storage to complex data manipulation. Whether you're working with a list of numbers, a collection of user information, or nested data structures, arrays provide a structured way to handle these scenarios. PHP supports 3 primary types of arrays: indexed arrays, which use numeric keys to access elements; associative arrays, which use named keys for more intuitive data retrieval; and multidimensional arrays, which allow for nested structures to represent complex relationships. Understanding these array types is foundational for effective PHP programming. Indexed arrays are the most straightforward type, using numeric keys to store and access elements. For example, a list of fruits can be represented as fruits equals apple, banana, where each element is accessed by its position in the array. Associative arrays, on the other hand, use string keys to provide meaningful labels for data, such as ages equals Alice equals 30, making it easier to retrieve specific information. Multidimensional arrays take this concept further by containing one or more arrays within them, such as a matrix represented as matrix equals 1, 2, 3, 4. These structures are particularly useful for modeling real-world scenarios like tables, grids, or hierarchical data. Each type of array serves a unique purpose, and knowing when to use which can greatly enhance the efficiency and clarity of your code. creating arrays in PHP is simple and versatile. The traditional method uses the array function, as in numbers equals array 1, 2, 3, while the shorthand syntax numbers equals 1, 2, 3 is more modern and readable. For associative arrays, you can assign key-value pairs directly, such as person equals name equals John, age equals 25. This allows for clear and structured data representation. When working with arrays, it's important to note that keys can be either integers or strings, and values can be of any data type. Whether you're initializing a small list of items or a complex dataset, PHP's array syntax provides the flexibility to adapt to your needs. Accessing elements within an array depends on the type of array you're working with. In indexed arrays, elements are accessed using their numeric index, starting from 0. For example, fruits 0 would retrieve apple from the array fruits equals apple, banana. Associative arrays use their named keys to retrieve data. So ages Alice would return 30 in the example ages equals Alice equals 30. Multi-dimensional arrays require multiple indices to access elements, such as matrix 10, which would retrieve the value 3 from the array matrix equals 1, 2, 3, 4. This layered approach allows for precise control over nested data structures, making it easier to manage complex information. PHP provides several built-in functions to work with arrays, making it easier to manipulate and analyze data. The count function returns the number of elements in an array, which is useful for determining size or validating data. The for each loop is a powerful tool for iterating through arrays, allowing you to perform actions on each element without manually managing indices. Functions like arrayPush add elements to the end of an array, while arrayMerge combines multiple arrays into one. These functions streamline common tasks, reducing the need for repetitive code and improving overall efficiency. Mastery of these tools is essential for effective array handling in PHP. Multi-dimensional arrays are arrays that contain one or more arrays, enabling the representation of complex data structures. For instance, a two-dimensional array can model a table of data, such as a list of students with their respective grades, where each student's information is stored as a nested array. This structure is particularly useful in scenarios like databases, where relationships between data points need to be preserved. Another example is a matrix, which uses nested arrays to store rows and columns of numerical values. By organizing data in this way, developers can create more intuitive and manageable code, especially when dealing with hierarchical or tabular information. Working with multidimensional arrays involves accessing elements through multiple indices, such as students 0, 1, which retrieves the second element of the first nested array. This requires careful attention to the structure of the array to ensure correct data retrieval. Nested loops are often used to iterate through all elements, allowing you to process each value systematically. For example, a loop within a loop can traverse every row and column of a matrix. Additionally, functions like ArrayMap and ArrayFilter can be applied to nested arrays to perform operations on each element, such as transforming data or filtering specific values. These techniques are invaluable for tasks like data analysis or processing large data sets. Practical examples of arrays in PHP include storing user data in associative arrays, where each key represents a specific attribute like name or email. This makes it easy to retrieve and manage information. Another common use is representing a grid of values as a two-dimensional array, which can be used in applications like game development or spreadsheet-like data structures. Multi-dimensional arrays are also ideal for configuration settings, where different sections of a program can be organized into separate nested arrays. These examples demonstrate how arrays provide a structured and scalable way to handle data, making them a cornerstone of PHP development. Arrays are a fundamental component of PHP programming, offering a structured way to store, access, and manipulate data. By mastering indexed, associative, and multidimensional arrays, developers can create more efficient and organized code. These structures are not just theoretical tools, but are essential for real-world applications, from handling form data to managing complex datasets. Practicing the creation, access, and manipulation of arrays will significantly enhance your ability to solve programming challenges. As you continue to explore PHP, you'll find that arrays are a versatile and indispensable part of your toolkit, enabling you to build robust and scalable applications. Sorting arranges array elements in a specific order, such as ascending or descending. This helps organize data for easier access and analysis. Filtering, on the other hand, extracts elements that meet specific conditions, allowing you to focus on relevant information. PHP offers a range of built-in functions to handle these tasks efficiently. Whether you are working with numeric data, strings, or complex associative arrays, sorting and filtering are fundamental techniques for managing and transforming data. These operations are especially valuable when dealing with large data sets, as they enable you to extract insights and prepare data for further processing. PHP provides several functions for sorting arrays. The sort function sorts values in ascending order and reindexes the array keys, which is useful when you only need the values. The assort function sorts by value, but keeps the key value associations intact, making it ideal for associative arrays. The ksort function sorts by key in ascending order, which is helpful when the keys themselves hold significance. For descending order, the rsort function reverses the sort of sort, and rsort does the same for a sort. Similarly, krsort sorts keys in descending order. Choosing the right function depends on whether you need to preserve keys or sort by values versus keys. Filtering arrays in PHP allows you to refine data based on criteria. The array filter function removes elements that evaluate to false, such as empty strings or zero, making it useful for cleaning data. The ArrayMap function applies a callback to each element, transforming values or performing operations like converting strings to uppercase. The ArrayReduce function processes the array to produce a single result, such as summing all elements or concatenating strings. Custom filters can be created using anonymous functions, giving you flexibility to validate input or modify data dynamically. These techniques are essential for tasks like data validation, transformation, and preparing information for output. When default sorting functions are insufficient, PHP allows custom sorting using callbacks. The usort function sorts an array using a user-defined comparison function, enabling complex logic like sorting by a specific property. The usort function works similarly, but preserves key value associations, ensuring data integrity. The uxort function sorts keys based on a custom comparison, which is useful for manipulating associative arrays. For example, you might sort an array of objects by a name or date field. Callbacks provide the flexibility to handle unique sorting requirements, making these functions powerful tools for advanced data manipulation. Let's explore practical examples of sorting and filtering. To sort a numeric array, use sort $array for ascending order or rsort for descending. Filtering even numbers can be done with array filter and a callback that checks if a value is divisible by 2. Sorting an associative array by value is straightforward with a sort, while sorting by a specific property requires usort and a custom comparison. For instance, sorting by a name field involves comparing the name values of each element. Combining these techniques allows you to process data more effectively, such as filtering, and then sorting results to meet specific requirements in applications like data reporting or user management. Sorting and filtering are essential skills for working with arrays in PHP. Select the appropriate function based on whether you need to preserve keys or sort by values versus keys. Use callbacks for custom logic when default functions do not suffice. Always test your code with sample data to verify behavior, especially when dealing with edge cases. Practicing with real-world scenarios, such as handling form inputs or processing database queries, will help reinforce these techniques. By mastering these operations, you can efficiently manage and analyze data, making your PHP applications more robust and versatile. Constants in PHP are identifiers that hold values which remain fixed throughout the execution of a script. Unlike variables, which can change, constants are designed to store information that should not be altered once defined. By default, constants are case sensitive, meaning that a constant named pi is different from pi. However, this behavior can be modified by using the third parameter in the define function, which allows for case-insensitive constants. These are particularly useful for storing configuration settings, such as database connection details or mathematical values like the number pi, which remains constant across calculations. Using constants helps prevent accidental changes and improves code readability by making the purpose of values clear. To define a constant in PHP, you can use either the define function or the const keyword. The define function is a built-in function that takes 3 arguments: the name of the constant, its value, and an optional third parameter to specify case sensitivity. For example, define pi. 3.14159 creates a constant named pi with the value 3.14159. Alternatively, the const keyword is used to declare constants at the top level of a script or within a namespace. For instance, const maxusers equals 100 creates a constant named maxusers with the value 100. Constants declared with const are typically preferred in object-oriented programming because they are more readable and can be used within classes. Both methods make constants globally accessible, meaning they can be used anywhere in the script without needing to be passed as parameters. Accessing constants in PHP is straightforward. Once a constant is defined, you can reference it by its name without using a $sign, unlike variables. For example, echo pi will output the value of the pi constant. Constants can also be used within strings, allowing for dynamic content generation. For instance, echo, the value is pi, will display the value is 3.14159 if pi is defined. However, it is important to note that constants should not be used for values that may change during runtime. Using constants for such values can lead to errors or unexpected behavior, as trying to reassign a constant's value will result in a runtime error. This makes constants ideal for storing fixed data, such as application settings or fixed mathematical values. Magic constants in PHP are a special type of predefined constants that provide information about the script's current context. Unlike regular constants, magic constants do not need to be explicitly defined. Their values are determined at runtime and can vary depending on how they are used. For example, the line magic constant returns the current line number in the script, while file provides the full path and file name of the current file. These constants are particularly useful for debugging, logging, or generating dynamic content based on the script's environment. Because their values are determined at runtime, magic constants offer flexibility and can adapt to different situations without requiring manual updates. Some of the most commonly used magic constants in PHP include line, file, dir, function, and class. The line constant returns the current line number in the script, which is helpful for error messages or debugging. The file constant provides the full path and file name of the current file, making it useful for including other files or determining the script's location. The dir constant returns the directory of the current file, which is often used to construct relative paths. The function constant returns the name of the current function in lowercase, while class returns the name of the current class in lowercase. These magic constants allow developers to create more dynamic and context-aware code without hard-coding values. Let me demonstrate some practical examples of magic constants. For instance, echo line number. Line will output the current line number, which is useful for tracking where an error occurs. Similarly, echo file. File displays the full path and file name of the current script, which can be used to verify the script's location. The dir constant can be used to construct dynamic paths, such as echo directory. Dir, which outputs the directory of the current file. When used within a function, the function constant returns the function's name, as seen in the example function myFunction, echo function, which would output myFunction. These examples highlight how magic constants can simplify development by providing real-time context information. When working with constants, it is essential to follow best practices to ensure code clarity and maintainability. First, always use uppercase names for constants to distinguish them from variables, such as maxusers instead of max users. This makes the code more readable and reduces the risk of naming conflicts. For class-level constants, prefer the const keyword over define, as it is more readable and integrates better with object-oriented programming. Magic constants are best used for debugging or dynamic path handling, as they provide valuable runtime information. However, avoid overusing them in production code, as they can make the code harder to understand and maintain. By following these guidelines, you can leverage constants and magic constants effectively to create robust and efficient PHP applications. In summary, PHP constants offer a reliable way to store fixed values that remain unchanged during script execution. They are essential for maintaining consistency and preventing errors caused by accidental modifications. Magic constants, on the other hand, provide dynamic information about the script's context, making them invaluable for debugging and file handling. Understanding both types of constants enhances your ability to write efficient, maintainable, and scalable code. As you continue learning PHP, practice defining and using constants in real-world scenarios, such as configuring applications or generating dynamic patterns. paths. By mastering these concepts, you will improve your ability to create clean, professional-grade code. PHP sessions are a powerful tool for maintaining user data across different pages of a website. When a user interacts with a PHP application, the session allows the server to store information that persists beyond a single request. This is especially useful for things like user authentication, where you need to remember a user's login status as they navigate through the site. Sessions work by generating a unique session ID, which acts as a key to retrieve the stored data. This ID is typically stored in a cookie on the user's browser or passed through the URL, but the actual data remains on the server, making it more secure than cookies, which are stored on the client side. By using sessions, developers can ensure that sensitive information like authentication tokens or user preferences are handled safely and efficiently. To get started with PHP sessions, you need to call the session start function, which is session start. This function initializes a session and creates a unique session ID if one doesn't already exist. Once the session is active, PHP automatically handles the session ID, storing it in a cookie by default. This means that as the user navigates through the site, the server can identify their session and retrieve the associated data. The session data itself is stored on the server, often in files or a database, depending on the configuration. This server-side storage ensures that the data is not exposed to the client, reducing the risk of tampering. Sessions remain active until the user closes their browser or the session expires, which is typically determined by a predefined time limit set in the PHP configuration. One of the key advantages of PHP sessions is their ability to maintain persistent user data across multiple requests. This is essential for creating a seamless user experience, as it allows the application to remember the user's state without relying on client-side storage. Sessions also provide a secure way to store sensitive information, such as login credentials or user preferences, because the data never leaves the server. Unlike cookies, sessions can handle complex data types like arrays and objects, making them versatile for various applications. Additionally, PHP's built-in session functions integrate smoothly with the language, allowing developers to easily store and retrieve data using the session superglobal. This combination of security flexibility, and ease of use makes sessions a fundamental part of PHP development. Managing sessions in PHP involves using the session superglobal, which is a special array that stores session data. To access or modify session data, you simply use the session array like you would with any other global variable. However, before you can use the session superglobal, you must call session start, which initializes the session and makes the data available. It's crucial to call this function before any output is sent to the browser, as session data relies on HTTP headers, which cannot be modified after the response begins. When a user logs out or the session is no longer needed, you can destroy the session using session destroy, which removes all session data from the server. To clean up specific data, you can use the unset function to remove individual keys from the session array, ensuring that only necessary information is retained. Security is a critical aspect of session management, and there are several best practices to follow. One important consideration is to avoid exposing session IDs in URLs, as this can make them vulnerable to interception. Instead, rely on cookies to store the session ID, which is more secure when configured properly. Another key measure is to use the session regenerate ID function, which changes the session ID periodically to prevent session fixation attacks, where an attacker might guess or steal a session ID. Enabling secure and HTTP-only flags on session cookies ensures that the session ID is only transmitted over HTTPS and cannot be accessed by JavaScript, reducing the risk of cross-site scripting attacks. Finally, setting a short session lifetime helps minimize the window of opportunity for attackers to exploit a session, ensuring that inactive sessions are automatically cleared. Following best practices for session management is essential for maintaining the security and efficiency of your PHP applications. Always start the session with session start at the beginning of your script to ensure that session data is available throughout the request. Store only the minimal amount of sensitive data in sessions, as keeping too much information can increase the risk of exposure. Using HTTPS is a must, as it encrypts all data transmitted between the client and server, including the session ID, protecting it from eavesdropping. Regularly cleaning up expired sessions helps free up server resources and prevents the accumulation of outdated data. By adhering to these practices, developers can create robust, secure applications that provide a reliable user experience while minimizing potential vulnerabilities. In summary, PHP sessions offer a secure and efficient way to store and manage user data across multiple pages. By understanding how sessions work and implementing proper management techniques, developers can enhance the security and functionality of their applications. Following best practices, such as using secure cookies, regenerating session IDs, and limiting session lifetimes, helps protect against common threats like hijacking and fixation. Practicing the use of session functions like session start, session destroy, and the session superglobal is essential for building real-world applications. With careful implementation and attention to security, PHP sessions can be a powerful tool in any developer's toolkit. PHP sessions are a fundamental tool for maintaining user state across multiple web pages. When a user interacts with a website, session data allows the server to remember information about that user without relying on cookies or other client-side storage. To use sessions, the function session start must be called at the beginning of every script. This function initializes a session or resumes an existing one, enabling the storage of data in the session superglobal array. This array, known as session, acts like a global variable that persists between requests. When a session is no longer needed, the session destroy function is used to terminate it. Although the actual data may remain on the server until the garbage collector removes it. Proper session management ensures that user data is securely maintained and efficiently accessed. However, sessions are not without risks. One major threat is session hijacking, where an attacker intercepts a session ID to impersonate a user. This can occur if the session ID is transmitted insecurely or if it is predictable. Another risk is session fixation, where an attacker forces a user to use a known session ID, often by tricking them into clicking a malicious link. Insecure storage of session data is also a concern, as default session handlers may leave files vulnerable to unauthorized access. Additionally, cross-site request forgery, or CSRF, exploits the trust a website has in a user's browser to perform unintended actions. These vulnerabilities highlight the importance of securing session management to protect both users and applications. To mitigate these risks, developers should adopt best practices for session security. First, always call the session start function at the very beginning of a script to ensure the session is properly initialized. After a user logs in, regenerate the session ID using the session regenerate ID function to prevent session fixation attacks. Enable HTTPS to encrypt data transmitted between the client and server, protecting session IDs from interception. In the PHP configuration file, set the session cookie secure flag to ensure cookies are only sent over secure connections, and use the session cookie HTTP only flag to prevent JavaScript from accessing session cookies. These measures create a robust defense against common session-related threats. Preventing session fixation requires careful handling of session IDs. The session ID should be generated using a cryptographically secure random number generator, making it unpredictable to attackers. After a user authenticates, the session regenerate ID function with the parameter true is used to discard the old session ID and create a new one. This ensures that even if an attacker had previously obtained a session ID, it becomes invalid after the user logs in. By separating the session ID from the login process, developers significantly reduce the risk of session hijacking. This practice is especially critical for applications that handle sensitive information or require persistent user authentication. Cross-site request forgery attacks can be thwarted by implementing anti-CSRF tokens. These are unique, random values generated for each user session and included in forms or requests. When a request is made, the server verifies that the token matches the one stored in the session, ensuring the request originated from the intended user. Setting the same site attribute on session cookies to strict or lax further limits how cookies are sent with cross-origin requests, reducing the attack surface. While checking the referrer header can add an extra layer of security, it is not foolproof and should be used in conjunction with other measures. Combining these strategies helps prevent unauthorized actions executed on behalf of a user. Secure session storage is essential for protecting data at rest. By default, PHP stores session files in a directory accessible to the server, which could be vulnerable to attacks if not properly configured. Developers should move session files to a directory outside the web root or restrict access using file permissions. For applications with high traffic, using a database or distributed cache like Redis for session storage offers scalability and better security. Never store sensitive data such as passwords or credit card numbers in the session. Regularly cleaning up expired session files with the garbage collector ensures that old data does not accumulate, reducing the risk of exposure. Advanced session management techniques allow for greater flexibility and security. Custom session handlers can be implemented to store session data in alternative locations, such as a database or in-memory cache, providing more control over session lifecycle. Persistent sessions, which remain active even after the browser is closed, require careful handling to prevent unauthorized access. Setting session timeouts ensures that inactive sessions are automatically terminated, reducing the window of opportunity for attacks. Monitoring session activity for unusual patterns, such as rapid login attempts or unexpected geographic locations, can help detect and respond to potential threats in real time. These advanced strategies enhance the overall security posture of web applications. Leveraging PHP security extensions further strengthens session protection. The Suhasin patch adds additional security features, such as stricter validation of input data and enhanced session management. The OPCache extension improves performance while also providing security benefits by reducing the attack surface. Built-in functions like filter var and filter input can sanitize user input, preventing injection attacks that might exploit session data. Keeping PHP and its extensions up to date is crucial, as updates often include security patches for known vulnerabilities. By combining these tools with secure coding practices, developers can create a more resilient application. Real-world examples demonstrate how these practices can be applied. For instance, in a secure login flow, after verifying a user's credentials, the session regenerate ID function is called to generate a new session ID, invalidating any previous session. This prevents session fixation by ensuring the attacker cannot use an old session ID. Anti-CSRF tokens are embedded in forms and validated on the server, ensuring that requests are legitimate. Renaming the session ID using the session name function adds another layer of obscurity, making it harder for attackers to guess or manipulate session identifiers. These steps, when implemented correctly, create a secure environment for user interactions. In conclusion, session security is a critical aspect of web development that requires careful attention. By understanding the risks and implementing best practices, developers can protect user data and prevent common attacks. Techniques such as session regeneration, secure storage, and anti-CSRF measures form the foundation of a secure session management system. Staying informed about PHP updates and security extensions ensures that applications remain protected against evolving threats. Ultimately, a proactive approach to session security is essential for maintaining user trust and the integrity of web applications. PHP is a powerful server-side scripting language that plays a crucial role in web development. It allows developers to create dynamic web pages by executing code on the server before sending the results to the client's browser. RESTful APIs, on the other hand, are a set of architectural principles that enable applications to communicate over the web. They rely on standard HTTP methods to perform actions like retrieving or updating data. By the end of this session, you will gain a solid understanding of PHP fundamentals and learn how to design and implement RESTful APIs to build modern, scalable web services. PHP stands for Hypertext Preprocessor, a language specifically designed for web development. It runs on the server, processes data, and generates HTML that is then sent to the client. This makes it ideal for creating dynamic content, such as user authentication, database interactions, and real-time data updates. Unlike client-side languages like JavaScript, PHP operates behind the scenes, handling tasks that require server resources. Its simplicity and flexibility have made it a popular choice for developers worldwide. One of PHP's greatest strengths is its cross-platform compatibility, allowing it to run seamlessly on Windows, Linux, and macOS. It supports a wide range of databases, including MySQL, PostgreSQL, and MongoDB, making it versatile for different data storage needs. PHP integrates effortlessly with HTML, enabling developers to embed code directly into web pages for dynamic content. Additionally, its large and active community provides extensive documentation tutorials and libraries, ensuring that developers can find solutions to almost any problem they encounter. REST-TFL APIs are based on the REST architectural style, which emphasizes simplicity and scalability. They act as intermediaries, allowing different applications to exchange data over the internet. For example, a mobile app might use a REST-TFL API to fetch user information from a server. These APIs use standard HTTP methods like GET to retrieve data, POST to submit data, PUT to update existing data, and DELETE to remove data. This standardized approach ensures that APIs are intuitive and easy to use across various platforms and technologies. The principles of REST ensure that APIs are efficient and maintainable. Statelessness means each request is independent, so the server does not need to store session data, improving scalability. The client-server model separates the user interface from the data storage, allowing both components to evolve independently. A uniform interface simplifies interactions by using consistent resource identifiers, such as URLs, and standard methods for data exchange. Finally, cacheable responses reduce server load by storing frequently accessed data, enhancing performance for users. PHP is well suited for building REST-TFL APIs, whether using frameworks or raw code. Frameworks like Laravel and Slim provide tools to structure API development, handle routing, and manage authentication. However, even basic PHP can create simple APIs by processing HTTP requests and returning data in formats like JSON or XML. This flexibility allows developers to choose the approach that best fits their project's complexity and requirements, making PHP a versatile choice for both small and large-scale applications. Let's walk through an example of creating a REST endpoint to retrieve user data. First, we detect the HTTP method using the requestmethod superglobal to determine if the request is a GET, POST, or another method. For a GET request, we might query a database and return the results as a JSON encoded response using the JSON encode function, ensuring proper validation and error handling is critical, as it prevents invalid input from causing issues and provides meaningful feedback to the client. This approach forms the foundation of many real-world APIs. Security is paramount when developing APIs. Always validate and sanitize user inputs to prevent attacks like SQL injection or cross-site scripting. Using HTTPS encrypts data transmitted between the client and server, protecting sensitive information. Implementing authentication mechanisms such as API keys or OAuth ensures only authorized users can access protected resources. Finally, handle errors gracefully by returning appropriate HTTP status codes and avoiding detailed error messages that could expose vulnerabilities. These practices safeguard both the application and its users. In summary, PHP is a foundational tool for server-side logic in REST-TFL APIs, enabling dynamic web services. REST-TFL APIs provide a scalable and interoperable way for applications to communicate, making them essential in modern development. To master these concepts, hands-on practice is key. Experiment with building APIs using PHP and explore frameworks like Laravel for more advanced features. Future sessions will delve deeper into these topics, equipping you with the skills to create robust and secure web services. REST API stands for Representational State Transfer Application Programming Interface. It is an architectural style that allows systems to communicate over the web using standard HTTP methods. This approach is widely used because it is simple, scalable, and works well with the web's existing infrastructure. By following REST principles, developers can create APIs that are intuitive and easy to use. PHP is particularly well suited for this task because it is flexible, has a large ecosystem, and can handle the lightweight nature of REST-TFL services. This makes it a popular choice for building APIs that power everything from mobile apps to web services. To build a REST API in PHP, you need a few key components. First, ensure you have PHP 7 or a newer version installed, as it offers improved performance and features like scalar type declarations. You will also need extensions such as JSON for handling data serialization and PDO for interacting with databases. A web server like Apache or Nginx is essential for hosting your API, or you can use local environments like XAMPP or WAMP for development. A code editor such as VS Code or Sublime Text will help you write and debug your code efficiently. Finally, a basic understanding of PHP and the HTTP protocol is crucial, as it allows you to manage requests, responses, and the flow of data between clients and servers. Setting up a project for a REST API involves organizing your files in a logical structure. Begin by creating a dedicated folder, such as REST API, to keep everything contained. For testing, you can configure a virtual host on your web server, or use the built-in PHP development server with the PHP-S command. This helps simulate a live environment locally. Next, structure your project into directories like controllers, models, and config. Controllers handle incoming requests. Models interact with the database, and config stores settings like database credentials. Finally, create an entry point, such as index PHP, which acts as the central hub for all API requests, routing them to the appropriate handlers. Creating a simple endpoint in PHP requires detecting the HTTP method used by the client. For example, if a user sends a GET request to /API/data, your code should retrieve data and return it in a structured format. Conversely, a POST request might expect JSON input, which you then process and store. It is important to set the correct HTTP status codes to indicate the outcome of the request. For instance, a 200 status code means success, while a 405 code signals that the method is not allowed. This ensures clients understand the result of their actions and handle errors appropriately. Each HTTP method serves a specific purpose in a REST API. The GET method is used to retrieve data, such as fetching a list of users from a database. The POST method is for creating new resources, like adding a new user. PUT is used to update existing resources, such as modifying a user's details, while delete removes a resource entirely. These methods align with the CRUD create, read, update, delete operations, and ensure that your API follows a consistent and predictable pattern. By adhering to these standards, developers can build APIs that are easier to understand and maintain. Working with JSON is a fundamental part of building REST APIs, as it provides a lightweight format for data exchange. In PHP, the JSON encode function converts arrays or objects into JSON strings, making it easy to send data to clients. Conversely, JSON decode parses incoming JSON data into PHP variables for processing. It is essential to set the content type header to application/JSON to inform clients that the response is in JSON format. For example, when returning a success message, you might use echo JSON encode status equals success, data equals result to ensure the client receives structured data. Let's look at an example of a simple resource, such as a user's endpoint. The GET method at /API/users can return a list of all users by querying a database and formatting the results as JSON. The POST method allows clients to add new users by accepting JSON input, validating it, and inserting it into the database. Proper input validation is critical here to prevent errors or malicious data from being stored. For instance, checking that required fields like name and email are present ensures the data is consistent and reliable. This approach makes the API robust and user-friendly. Extending this example, a CRUD create, read, update, delete implementation for users requires additional endpoints. The GET method at /API/users/ID retrieves a specific user by their ID, while the PUT method updates their details. The delete method removes a user entirely. Each of these operations must include error handling to manage cases like invalid IDs or missing data. For example, if a client requests a user that does not exist, the API should return a 404 not found status code and a descriptive message. This ensures the client knows how to handle such scenarios gracefully. Error handling is crucial for a reliable API. Using HTTP status codes, you can communicate the nature of errors clearly. A 400 bad request indicates invalid input. A 404 not found means the resource was not found. And a 500 internal server error signals an unexpected issue on the server. Alongside status codes, providing detailed error messages in JSON helps clients understand what went wrong. For example, if a user submits incomplete data, the API might respond with a 400 status code and a message like error, missing required fields. This transparency improves the user experience and simplifies debugging. Testing your API ensures it works as intended. Tools like Postman or CURL allow you to send requests and inspect responses. For example, you can test a GET request to /API/users to verify it returns the correct data. It is also important to test edge cases, such as sending invalid methods or missing parameters, to ensure the API handles them gracefully. By simulating various scenarios, you can identify and fix issues before deploying the API. This step is essential for maintaining the reliability and security of your service. In conclusion, REST APIs enable seamless communication between systems, making them a cornerstone of modern web development. PHP's flexibility and simplicity make it an excellent choice for building these APIs, even for complex applications. As you practice creating endpoints, handling HTTP methods, and managing JSON data, you will gain the skills needed to develop robust APIs. To further enhance your knowledge, explore advanced topics like authentication, rate limiting, and documentation. These concepts will help you build APIs that are not only functional, but also secure and scalable. PHP frameworks are pre-built structures that simplify web development. They act as a foundation for building applications by providing tools, libraries, and conventions that streamline the coding process. This means developers don't have to start from scratch every time they create a new project. Instead, they can leverage existing components to handle common tasks like user authentication, data validation, and database interactions. Popular frameworks include Laravel, Symfony, CodeIgniter, and Zend, each offering unique features and approaches. By using these frameworks, developers can focus more on solving specific problems rather than reinventing the wheel. They also help enforce best practices, ensuring code is organized, secure, and easier to maintain over time. This reduces the amount of repetitive coding and helps teams work more efficiently. Using PHP frameworks offers several advantages that make web development faster and more reliable. One of the main benefits is that they streamline development by providing predefined components and structures. For example, instead of writing custom code for routing or database connections, developers can use built-in tools that handle these tasks. This not only saves time, but also reduces the chances of errors. Frameworks also improve code organization and maintainability by enforcing a consistent structure across projects. This is especially important in team environments where multiple developers work on the same code base. Security is another key factor, as frameworks often include built-in features like authentication systems, input validation, and protection against common vulnerabilities such as SQL injection or cross-site scripting. Finally, frameworks support scalability, allowing applications to grow smoothly as user demands increase. They also make collaboration easier by providing clear guidelines and shared resources. Laravel is a modern, open-source PHP framework that has gained widespread popularity for its elegant syntax and robust features. It was created to make PHP development more enjoyable and productive, offering a balance between simplicity and power. Laravel is built on the Model View Controller MVC architecture, which separates application logic into 3 interconnected components. This separation makes it easier to manage complex applications and allows for more scalable and maintainable code. Laravel is widely used for building web applications, content management systems, and APIs. Its versatility makes it suitable for both small projects and large-scale enterprise applications. The framework's clean and expressive syntax also makes it accessible to developers of all skill levels, from beginners to experts. Laravel offers a range of key features that make it a powerful tool for web development. One of these is the Blade templating engine, which allows developers to create dynamic views with a simple and intuitive syntax. Blade makes it easy to embed PHP code within HTML, while also supporting advanced features like template inheritance and conditional rendering. Another important feature is Eloquent, Laravel's object relational mapper, which simplifies database interactions by allowing developers to work with database records as if they were PHP objects. Artisan is the command line interface included with Laravel, providing a suite of tools for generating code, running migrations, and managing other routine tasks. Laravel also includes built-in authentication systems, making it easy to handle user registration, login, and password recovery. Additionally, the framework's strong community support and extensive documentation ensure that developers have access to resources and solutions for almost any problem they might encounter. The Laravel project structure is designed to organize code in a logical and maintainable way. The app directory contains the core application code, including controllers, models, and services. Controllers handle incoming HTTP requests and return responses. Models interact with the database, and services encapsulate business logic. The config/directory holds configuration files for settings like database connections, application environment, and routing. The database directory is where migrations and seeders are stored, allowing developers to manage database schema changes and populate initial data. The public directory contains assets such as CSS, JavaScript, and images that are accessible to the web browser. Finally, the routes directory defines the application's URL routes and middleware, acting as the entry point for handling incoming requests. This structured approach ensures that code is organized, easy to navigate, and scalable. Setting up a Laravel project involves a few straightforward steps. First, you need to install PHP and Composer on your system. PHP is the server-side scripting language, while Composer is a dependency manager that helps install and manage packages. Once PHP and Composer are installed, you can use Composer to create a new Laravel project by running the command composer create project Laravel/Laravel. This command downloads and sets up the Laravel framework in a new directory. After the project is created, you can start the built-in development server by running PHP artisan serve, which allows you to test your application locally. Finally, you can access the application by opening a web browser and navigating to http://localhost 8000, where you'll see the default Laravel welcome page. This setup provides a quick way to begin developing and testing your application. The Model View Controller MVC architecture is a fundamental concept in Laravel and other modern web frameworks. The model represents the data and business logic of the application, typically interacting with the database through eloquent ORM. The view is responsible for the user interface, displaying data to the user and capturing their input. This is where blade templates come into play, allowing dynamic content generation. The controller acts as the intermediary between the model and view, processing incoming requests, retrieving data from the model, and passing it to the view for rendering. This separation of concerns ensures that each component has a single responsibility, making the application easier to manage, test, and scale. For example, when a user visits a web page, the controller handles the request. The model fetches the necessary data, and the view formats it for display. Laravel's ecosystem extends beyond the core framework with a variety of tools and extensions. Laravel Nova is an admin panel that provides a powerful interface for managing application data, allowing developers to create, edit, and delete records with ease. Laravel Mix is a tool for compiling front-end assets like CSS and JavaScript, making it simple to optimize and manage style sheets and scripts. Laravel Passport offers a secure way to handle API authentication, enabling developers to create and manage OAuth 2 tokens for third-party applications. Laravel Forge is a server management tool that simplifies deployment and maintenance, allowing developers to configure servers, deploy applications, and monitor performance with minimal effort. These tools work seamlessly with Laravel, enhancing its capabilities and making it a comprehensive solution for modern web development. Laravel's benefits make it a top choice for developers looking to build robust and scalable applications. One of the key advantages is its ability to accelerate development through pre-built tools and features. For instance, Laravel's scaffolding commands can generate boilerplate code for authentication, APIs, and more, saving significant time. The framework also emphasizes security with built-in protections against common vulnerabilities like cross-site request forgery, CSRF, and SQL injection. Laravel's scalability allows it to handle projects ranging from small websites to large enterprise applications, ensuring that the code base can grow without becoming unwieldy. Additionally, the active and supportive community contributes to a wealth of resources, including tutorials, packages, and forums, making it easier for developers to learn and troubleshoot issues. These factors, combined with regular updates and improvements, make Laravel a reliable and future-proof choice for web development. PHP frameworks like Laravel significantly simplify the process of building web applications by providing structured tools and best practices. Understanding core concepts such as MVC, routing, and ORM is essential for leveraging these frameworks effectively. Laravel's features and ecosystem make it a versatile and powerful option for developers, whether they are working on small projects or large-scale systems. The framework's emphasis on readability, security, and scalability ensures that applications are not only functional, but also maintainable and efficient. To master Laravel, it's important to explore its documentation thoroughly and apply the knowledge through hands-on projects. By doing so, developers can gain confidence in using Laravel to create high-quality web applications that meet modern standards and user expectations. Testing ensures code works as intended, while debugging identifies and fixes issues. In PHP, these processes are essential for building reliable applications. By testing, we verify that our code performs as expected, and through debugging, we pinpoint and resolve problems. PHP offers a range of tools to support both testing and debugging, making it easier to maintain high-quality code. The primary goals of these practices include minimizing errors, improving the ease of maintaining the code base, and ensuring consistent behavior across different scenarios. This approach not only saves time, but also enhances the overall user experience. Testing is crucial because it prevents regressions after code changes. When developers modify existing code, tests act as a safety net, ensuring that new updates do not break existing functionality. Testing also validates functionality across various scenarios, including edge cases and unexpected inputs, which helps uncover hidden issues. This process significantly improves code quality, giving developers confidence in their work. Additionally, in team environments, testing fosters collaboration by providing a shared understanding of how the code should behave, making it easier for team members to contribute without introducing errors. PHP has several powerful tools for testing and debugging. PHP Unit is a widely used framework for unit testing, allowing developers to write and execute tests for individual code components. Xdebug is a debugger that enables step-by-step execution, helping to trace the flow of code and identify issues. Blackfire is a performance profiling tool that highlights bottlenecks, ensuring applications run efficiently. Codeception is another framework that supports functional and acceptance testing, making it easier to simulate real-world user interactions. These tools collectively empower developers to build and maintain robust PHP applications. Error reporting in PHP is a critical aspect of development. During development, enabling display errors allows developers to see errors directly in the browser, which is invaluable for troubleshooting. Using error reporting, EEL ensures that all possible issues, from notices to fatal errors, are caught. Custom error handlers can be implemented to provide more user-friendly messages, avoiding the exposure of sensitive information. Logging errors with error log or other logging mechanisms allows for analysis after the fact, helping to identify patterns or recurring issues that may not be immediately visible during development. Debugging techniques in PHP involve various methods to inspect and resolve issues. Functions like vardump and printer are commonly used to examine the contents of variables, helping to understand their state during execution. Xdebug's Xdebug break allows setting breakpoints to pause execution and inspect the code step by step. The debug backtrace function provides a stack trace, revealing the sequence of function calls leading to an error. Browser extensions such as Xdebug Helper simplify the debugging process by integrating with the browser, making it easier to manage breakpoints and inspect variables without switching tools. Writing unit tests with PHP unit follows a structured approach. Developers create test classes that extend PHP unit /framework /test case, which provides a framework for writing and organizing tests. Assertions like assert equals and assert true are used to verify that the code behaves as expected. Running tests via the command line using vendor/bin/phpunit is a common practice, allowing for automated test execution. Mocking dependencies is another essential technique where external services or objects are simulated to isolate the unit under test, ensuring that tests focus on the specific functionality being evaluated. Logging and monitoring are vital for maintaining application health. The error log function is a basic tool for recording errors, while libraries like Monolog offer more advanced logging capabilities, including different log levels and output formats. Monitoring logs helps identify recurring errors or performance issues, enabling proactive fixes. Logging user actions and system events provides valuable insights into how the application is used and where problems may arise. For larger applications, centralized logging tools like the Elk Stack Elasticsearch, Logstash, Kibana allow for efficient aggregation and analysis of logs from multiple sources. Best practices for testing and debugging include writing tests before implementing features, a methodology known as test-driven development. This approach ensures that code is designed with testability in mind, leading to more reliable outcomes. Keeping test cases small and focused makes them easier to maintain and understand, reducing the risk of false positives. Version control systems like Git help track changes, making it simpler to identify when and why issues occurred. Regularly reviewing and updating test suites ensures that they remain relevant as the application evolves, maintaining their effectiveness over time. Testing and debugging are indispensable for creating robust PHP applications. By leveraging tools like PHP Unit and Xdebug, developers can streamline these processes, making them more efficient and effective. Prioritizing error handling and logging ensures that applications are not only functional, but also maintainable and scalable. Continuous practice in these areas helps improve code quality and reliability, fostering a culture of excellence in software development. Embracing these practices leads to more confident development and a better user experience. Performance optimization in PHP refers to the process of enhancing the speed and efficiency of your code to ensure that your applications run as smoothly as possible. This is critical because even the most well-designed applications can suffer from slow response times if not optimized properly. Efficient code not only improves scalability, allowing your application to handle more users without degradation in performance, but it also enhances the user experience by reducing load times and ensuring a more responsive interface. Common performance bottlenecks in PHP applications often include excessive database queries, inefficient algorithms, and lack of caching mechanisms. Addressing these issues can significantly improve the overall performance of your application. One of the most effective strategies for performance optimization in PHP is the use of caching. OP cache, for instance, stores precompiled script bytecode in memory, eliminating the need for PHP to load and parse scripts on each request. This drastically reduces processing time. File-based caching is another approach, where dynamic content is stored in files to avoid recalculating it repeatedly. This is particularly useful for content that doesn't change frequently. Additionally, leveraging external caching systems like Redis or Memcached can further enhance performance by storing data in memory across multiple servers, reducing the load on your primary database and improving response times for frequently accessed data. Database optimization plays a crucial role in the performance of PHP applications. Optimizing SQL queries involves using indexing to speed up data retrieval and analyzing query execution plans with the explain statement to identify inefficiencies. Reducing the number of database calls is equally important, which can be achieved through batch processing techniques that handle multiple operations in a single request. Connection pooling and persistent connections also help by maintaining open database connections, reducing the overhead of establishing new connections for each request. These strategies collectively minimize database latency and improve overall application performance. Code efficiency is another cornerstone of performance optimization. Avoiding unnecessary loops and deeply nested functions reduces the computational overhead and makes code easier to maintain. Built-in PHP functions are generally optimized at the language level, so relying on them instead of custom implementations can lead to faster execution. Minimizing variable scope by limiting the reach of variables and using static variables where appropriate helps reduce memory usage and improves code efficiency. These practices ensure that your code runs as quickly as possible while remaining clean and manageable. Opcode caching is a fundamental technique for improving PHP performance. Enabling OP cache by setting opcache enable to one ensures that compiled scripts are stored in memory, eliminating the need for repeated parsing. Configuring the opcache memory consumption parameter allows you to allocate sufficient memory for larger applications, preventing performance degradation due to memory constraints. However, it's important to regularly restart OP cache to clear outdated or corrupted data, which can lead to memory leaks and unexpected behavior over time. This practice ensures that your application benefits from the latest code changes without compromising performance. Minimizing HTTP requests is essential for reducing the load time of web pages. Combining CSS and JavaScript files into single bundles reduces the number of requests the browser must make, speeding up the loading process. Using image sprites, which combine multiple small icons into a single image file, further reduces the number of HTTP requests and improves rendering efficiency. Implementing browser caching through HTTP headers, such as cache control and expires, allows browsers to store static resources locally, reducing the need to re-download them on subsequent visits. These strategies collectively enhance the user experience by making web pages load faster. Profiling tools are invaluable for identifying performance issues in PHP applications. Xdebug provides detailed code profiling by measuring execution time and memory usage, helping developers pinpoint slow functions or memory-intensive operations. Analyzing these metrics allows for targeted optimizations. Blackfire, another powerful tool, offers advanced performance analysis by visualizing the flow of requests and highlighting bottlenecks. By leveraging these tools, developers can make data-driven decisions to improve application performance and ensure that resources are used efficiently. To achieve optimal performance in PHP applications, it is essential to prioritize caching, database optimization, and code efficiency. These areas often yield the most significant improvements in speed and scalability. Regularly profiling and monitoring your application helps identify emerging issues before they impact users. Staying updated with the latest PHP best practices and tools ensures that your application remains efficient as technologies evolve. By consistently applying these principles, developers can create robust, high-performing applications that meet the demands of modern web environments. Today, we will embark on a comprehensive journey to build a fully functional PHP application from the ground up. This final project is designed to solidify your understanding of PHP by applying the concepts we have covered in previous sessions. You will learn how to take an idea and transform it into a working application through a structured process. The project will follow 4 key phases: planning, development, testing, and deployment. Each phase will be critical in ensuring your application is not only functional, but also well organized and scalable. By the end of this project, you will have a tangible example of your PHP skills that you can showcase in your portfolio. Before writing a single line of code, we must take the time to plan our application thoroughly. Begin by defining the purpose of your application and identifying who your target audience is. For example, if you are building a task management tool, your audience might be students or professionals looking for a simple way to organize their daily activities. Next, outline the core features that your application must have. Common features include user authentication to ensure secure access, data management to store and retrieve information efficiently, and a user-friendly interface for interaction. Once the features are clear, create a project roadmap that includes specific timelines and milestones. This roadmap will help you track progress and stay on schedule as you move through the development process. A stable development environment is essential for any PHP project. To get started, install a local server such as XAMPP or WAMP, which provides a complete package including PHP, MySQL, and a web server. Once the server is running, configure your PHP settings to ensure compatibility with the latest versions of the language. Set up a code editor like Visual Studio Code, which offers powerful tools for writing and debugging PHP code. Finally, initialize a version control system such as Git to track changes to your code base. Version control will allow you to collaborate with others, revert to previous versions if needed, and maintain a clean and organized workflow throughout the project. A well-designed database is the foundation of any dynamic application. Start by planning your database schema, which includes defining the tables, columns, and relationships between them. For instance, if your application requires user accounts, you might create a users table with fields for username, email, and password. Use MySQL or a migration tool like Laravel's Artisan to create these tables and establish relationships between them. Once the structure is in place, implement CRUD operations create, read, update, and delete to manage data effectively. These operations will allow users to interact with the database, ensuring your application is both functional and responsive to user needs. The front end of your application is what users will see and interact with directly. Begin by designing user interfaces using HTML, CSS, and JavaScript to create a visually appealing and intuitive layout. HTML will structure the content, CSS will style it, and JavaScript will add interactivity. However, to make your application dynamic, you will integrate PHP to generate content on the server side. For example, PHP can pull data from the database and display it in real time. Ensure your layouts are responsive, meaning they adapt to different screen sizes, and accessible, so users with disabilities can navigate your application with ease. A well-crafted front end enhances the user experience and makes your application more engaging. The backend of your application handles the logic that drives its functionality. Write PHP scripts to manage business logic, such as processing user inputs, validating data, and interacting with the database. Implement session management to keep track of user activity across different pages, ensuring a seamless experience. Form validation is crucial to prevent incorrect or malicious data from being submitted. Connect your application to the database using either PDO or MySQLi, both of which provide secure and efficient methods for querying data. By organizing your backend code effectively, you will create a robust foundation that supports the features you have designed. Security is a critical aspect of any web application. Protect your application against common threats, such as SQL injection, where malicious code is inserted into database queries. Use prepared statements with PDO to prevent this. Also, guard against cross-site scripting XSS by sanitizing user inputs and outputting data safely. Implement password hashing using functions like password hash to store user passwords securely. Finally, establish user authentication and role-based access control to ensure only authorized users can perform specific actions. These measures will safeguard your application and its users, making it more trustworthy and reliable. Testing and debugging are essential steps to ensure your application works as intended. Perform unit testing to verify individual components, such as functions or classes, and integration testing to check how they interact. Use tools like PHP Unit to automate testing and catch errors early in the development cycle. When issues arise, debug them using error logs to identify the root cause and vardump to inspect variable values. A systematic approach to testing and debugging will help you create a stable and error-free application, reducing the risk of unexpected behavior in production. Once your application is functional, it's time to prepare it for deployment. Choose a hosting provider such as cPanel or Oz to make your application accessible online. Optimize your code for performance by minimizing database queries, caching frequently accessed data, and ensuring efficient use of resources. Scalability is also important, so design your application to handle increased traffic or data. Finally, plan for ongoing maintenance by setting up a process for updates, bug fixes, and incorporating user feedback. A well-maintained application will continue to serve its purpose effectively over time. In summary, this final project has guided you through the entire life cycle of building a PHP application, from planning and development to testing and deployment. Remember that writing clean, secure, and maintainable code is just as important as functionality. Always prioritize readability and organization in your code to make it easier to update or collaborate on in the future. As you complete this project, take pride in your work and share it with others to gain valuable feedback. This experience will not only enhance your technical skills, but also prepare you for real-world development challenges. Keep exploring, keep learning, and continue to refine your abilities as a PHP developer. And just like that, our dreamy coding adventure has come to an end. I hope the gentle ebb and flow of the tutorial, combined with the tranquil melodies, have left you feeling both informed and at ease. Whether you managed to catch every line of code or drifted off into a peaceful slumber, remember that the world of PHP will always be here waiting for you. Keep your code clean, your mind open, and your spirit relaxed. Don't forget to subscribe to Code Snooze so you never miss out on another soothing coding journey. Hit that like button if this video brought you a moment of calm and learning, and share it with fellow coders or anyone in need of a serene study session. Thank you for joining me in this cozy corner of the internet. Until next time, may your code run smoothly and your dreams be filled with brilliant algorithms. Sweet dreams, sleepy coders.